Slack space, so feel free to use that chat as well. Okay. So that other people who might be joining later can go back to the link as well. But otherwise, yeah, sure. Feel also free to use Zoom reactions. Oh, and it would be nice if, I mean, okay, everybody did that, but to keep yourself muted if somebody else is talking, just in case there are any background noises. So I'm gonna create the breakout rooms and make up short titles for your papers. I hope that's okay. If you don't recognize yourselves, then let me know and I can change the names. So depending on whether people are going to join at 2 straight, I would probably start like 1 or 2 minutes after 2. So if there's anything for you people where it's like super early, if you need more coffee, feel free to just run real quick. Hi, Iris. Are you presenting the second paper or is Tommy presenting the second paper?
I will present it.
Okay, thanks. Okay, I guess we can wait until Stephen is back and then Peter, you can start. Or I will introduce you and then you can start.
Okay.
All right, then thank you everybody for joining this USDC poster session. We will now hear a talk by Peter Holowka, Reimagining the Modern Physical Software Engineering Education and Training Environment.
Hi, welcome everybody. My name is Dr. Peter Holowka and I work at West Point Grey Academy in Vancouver, British Columbia. I also did my doctoral research at the University of Calgary. And so this is, I'm going to talk, and because of the brief format of this presentation, about the top of the glacier or the iceberg. So iceberg is more appropriate because you have the bottom of the iceberg, which is enormous, and then you have the top, which you see. And so in the bottom right, you're going to see a quick reference to a chart. This is the nature of cloud computing in Western Canada. My doctoral research through the University of Calgary was about IT infrastructure across the entire region, which is about a third of the size of the United States, 2.2 million square kilometers, 1.14 million plus students. And the implication was that cloud computing is a dominant factor. Every school district of size used cloud computing exclusively, with a few local installations of infrastructure to complement what they had in place. And so because all the schools had dominant cloud infrastructure, what was the implication for the classroom? And so this is where I'll now stop talking about the foundation and the bottom of the iceberg, and now I'll talk about what it means for the classroom and what it means about what it means for software engineering education. So you see up top, these are a couple of images of our modern classrooms being used, and these are where we teach computer science. Now, for the longest time, the challenge with computer science education was it required niche software that was difficult to license and install on user devices. With the pandemic, this approach became even more necessary and also affirmed our strategy going forward. So this is our premier computer lab. There are no computers. And what's important for us is that we give the students the ability to work anytime, anywhere. I come at this from a digital divide perspective, where yes, our school is an independent school that's very affluent, but this approach is very scalable to environments where people might have marginalized communities in their region, or the finances might be challenging. So really the key part of this is have a large bright projector, have a secondary display, and here you have the teacher's instructor station, where it's a computer with a screen and the instructor's laptop. And so whatever's on the laptop, on the screen here on the left, gets projected over. So this is what it looks like. Now, the technologies that are used for this are desktop virtualization environments, but not virtual desktop projector. Rather, this is desktop as a service and virtualization through the cloud exclusively. One of the trades early on was with virtual desktop infrastructure. You had in a server room on your campus powerful computers that run the thin client stuff. This, on the other hand, uses cloud computing infrastructure, which is very favorably priced for education. And what it means is that your institution, for very little money, can provide a custom desktop for a student. And then that desktop can follow the student home as well. So in our environment, students are required to just show up with a laptop and we'll provide everything else. And you sort of see the view is gorgeous of the city. You have a plug for the laptop. It's well thought out. So what I would recommend is going forward for institutions, as you design your computer science environments, to take this approach where you have a large projection space. You can sort of see it being used for detailed content, which again in computer science is important. And below on the right are some of the links. So the full study of IT infrastructure in Western Canada, they're presented here. And Amazon Web Services is one option for desktop virtualization. Cloudlize is another one. Microsoft Virtual Desktop environment. And of course, a link to all this literature is here. What does simulation and machine learning look like in a cloud environment? This would be an example. So this was full machine learning simulation running in the cloud using a Python algorithm. The students would launch this simulation training machine and walk away, which again solves the access to the computer lab problem. It also solves the problem of having to maintain the equipment in the lab with the expense of hiring IT talent, which is of course phenomenally expensive and difficult given the global talent shortage. And that's about it as I run out of 5 minutes.
Thank you. 4 minutes. That was perfectly in time. Thank you very much. I think since it's just us in here, does anybody have a question? We can do one question, I think, per talk.
Well, I'm curious now that you've tried this out, how's it working?
It's awesome. It's like just phenomenal. This is our approach, and like our community is, the owners of sports teams, and if they don't like it, they'll get on their private jet and fly elsewhere. And so we've had independent schools close in our region, and for us, this has been just a huge success. Our enrollment inquiries have doubled. We're harder to get into than Ivy League. And so it's been really validating, because the digital experience during COVID was the only experience for a school. And just the fact that we could continue the show without spending extra money when money was tight. We could provide devices when everyone else was lining up to buy additional servers and rack space and all that stuff. We already had it, and it was cheap. I would argue this is a cheaper approach than what most schools do already, and it's a better approach. So thanks for the question.
Okay, thank you. I'm sure we'll have great discussions afterwards. So the next person will be Benjamin Reid, teaching hands-on network management. The stage is yours.
Great, thank you. Yeah, my name is Ben Reid. I'm at San Jose State University. And this is a project I did when I first got here a little over 2 years ago. I was assigned to teach the network management class. It was a class that had been, it had gone stale. And I really wanted to give our experience, our students some good experience with real hardware, right? So they could have the real experience of managing networks. Now, there's a lot of really interesting ways of teaching network management with virtual environments, and those are really cool. And there's a lot of great work that has gone on in that area. But for my class, I wanted them to get some hands-on experience. I had come from industry, and I really wanted my students to be exposed to, real problems in a real environment. But that's expensive, and I did not have budget to build a real server farm that we could manage. I wanted to do group work. I wanted to have at least 10 devices that that these teams could manage and set up and provision. And I ended up using Raspberry Pis. So with these Raspberry Pis for well under $100 each, you can have a real server. And from a network standpoint, it looks real. From the experience standpoint, it is real. Like, these are real Linux machines. And it's worked out really great. We have here on the right, these are 80 Raspberry Pis that I have set up. We have 100 now for the class I'm teaching. On the left is a small microcluster that students can use kind of on a hands-on basis. Because of IT policies in our school, the students actually can't access the server room. So they get to learn these this network management and this hands-on in a very hands-off way. They never get to touch the Pis that they provision from scratch. So they write Pixie code to do Pixie boot. They do all the installation, all the monitoring. I induce failures. So it's been a really great experience, and the class has been very popular. We went from one class that wasn't full every year to this year we're doing 3. So it's been really cool and fun.
Okay, thank you. Any questions? I actually have one. How many students are you talking about?
Yeah, so we have generally I learned my first class I was doing groups of 6. That was too big. So now I do groups of 4, and my classes are 36 students with groups of 4. And that's worked out. It's right on the edge of manageable for me as far as workload goes, just to keep the class going. But that's worked out really well. And so with that we have 90 Pis that those 9 groups use.
Okay, any other questions for anybody? Or anything you want to know right now before we jump into the next presentation?
Yeah, I have a quick question, actually. So we're just looking at the next step in our program, and we're torn between Jetson Nanos or Raspberry Pis. If you could do it from scratch, which one would you go on?
The Raspberry Pis are extremely popular, and there's a lot of support out there. There's a lot of hardware. So I was really happy with how we went. And the hardware keeps getting refreshed. So I really like the Raspberry Pi option.
Thanks, Ben.
Okay, thank you. All right, so the next paper is our presenter is Muhammad Faisal, and on the floating satellite system as an educational platform for space applications. Stage is yours.
Hello, good afternoon, guys. My name is Muhammad Faisal, and I so I belong to University of Würzburg, Germany. In this project, we have developed a small laboratory-based floating satellite that we have developed for our bachelor and master student to perform the space-based education. This floating satellite is mainly consists on a mechanical structure that is a hemisphere, where we have a reaction wheel at the bottom and all the satellite systems on the upper part. That whole system is floating on a platform, which is an air-bearing unit. This air-bearing unit has compressed air as an input, which is coming in and that compressed air, the satellite is floating. The avionics of this float set is quite simple. We are using a very inexpensive Cortex M4 microcontroller board. There are very usual sensors like camera, light sensors, temperature sensors, IMU for the attitude controls, a DC motor with a reaction wheel, and also some very inexpensive radio communication modules like Wi-Fi and Bluetooth. And also we have the battery over there for the operation of the float set. The float set can go into different mode of operations, which is quite similar to the real satellite. For example, the deployment mode, motor speed control for the velocity mode, and also the position mode that I will show later. The software architecture is quite simple for the float set. It is based on a real-time, object-oriented, dependable operating system, which was developed by German Aerospace Center and our department in University of Würzburg. So there I have some demonstrations. So this float set is used in our bachelor's and master's course, where we are asking the students to make a small satellite, and this float set is like a benchmark for their projects. The satellite starts with the deployment mode, where the satellite rotates around its axis and search for the sun, and then go into different modes of operation. For example, to control the velocity of the satellite with the PIT controller, we also provide the student this platform to write their own controller, efficient one, and with the new strategies, and also with the artificial intelligence and different algorithms. So we provide them platform, and in this platform, they can write their new algorithms. And it can also have the ground station to display all the attitude parameter for the float set, and also the information regarding the other sensors. Then I have some demonstration. For example, the first demonstration is regarding the star tracking, where because we asked the student to make a complete satellite. This is the project which is based on the team, which is coming from the different perspective like mechanical, electronics, and also the computer science guys. So there are these kind of small demonstration of the float set. One was the star tracking, other was the analogous surface scanning of a three-dimensional planet, as you can see right here, that we get the data from the float set and try to project the surface of the planet. And then also some demonstration regarding the debris collection in the space. And we have also provided one demonstration regarding the docking between two satellites in the space. All these things are there to provide a student an excellent platform to do the real satellite experiment in their lab. So this is our project that we have developed here, and this is what we are using for the education in the bachelor and master's program. We have also contributed this satellite to many other universities in Europe, and we hope that it will provide a good test bed for the students of aerospace. Thank you.
Thank you. Sir, are there any questions?
I have a question.
Yeah, sure.
I'm curious, the components that you're using, are they all off the shelf, or do you have custom made pieces?
Actually, first when we made the satellite, all these components that they're shown, they are off the shelf component. We have not made anything. But you know, when you give these things to the students, there is a huge problem of connection and this. And then we made an extension board ourselves. This is the thing what we made ourselves. This is based on the sensors available in the market, but we have made this kind of extension board which will be joined with the development kit, so that a student does not need to perform any kind of wiring which might destroy the component, because you know in the lab you cannot let 10 teams destroying the components every day, because each one day will cost them 15-20 euro at least. So that is why we have make an extension board. This extension board contains all the sensors which are easily available in the market, but we have provided a kind of all together, so that we have a harness capability there, so that we avoid all the wiring and so on. That makes the development from the electronic point of view quite simple.
And were there different sizes, or was it just camera perspective?
Different sizes means what?
Like different sizes of the little satellite things, or
yes. For example, it depends. It depends on the mission what we have. For example, if you see in this mission, if you can see, we are doing the star tracking. Here we have standard size, but we have also additional platform for the mission. And then here, as you can see, here our mission was the analogous surface scanning. So we have some more components coming in the Z direction. So it depends on the mission of the float set.
Okay, thank you very much. That was very interesting. All right, next person. I think 5 minutes for you are okay after all, I guess. Tommy Kubika on towards the creation of customized teaching scenarios to support classroom interaction.
So, thank you and welcome from my side. My name is Tommy Kubika and I'm a PhD student from the city of Dresden in Germany. And I will present our tool demonstration with the title Towards the Creation of Customized Teaching Scenarios to Support Classroom Interaction. The main topic of our approach is about activating students in traditional or live stream lectures using their personal mobile devices. And our approach is motivated by the fact that current systems have predefined functional scopes due to single underlying didactic concepts. And this results in the problem that the lecturer has to adjust his preferred teaching strategy to the currently used system, instead of the system adapting to the lecture. And this is the goal of our approach, which is called Scenario-Tailored Audience Response System, or in short, STARS. Our approach allows to create customized workflows of interactive activities in order to support different kinds of interactions between the lecturer and the student and the lecturer, and also between students. And therefore, I prepared a short video demonstration in order to show you. First of all, we press on Create Scenario, we input the name of our scenario, and now we are ready to model our scenario. Which we see here is our modeling canvas, where we model everything which is visible on the student's devices. In this case, we add a pause block because in the first step, we just want to introduce to the lecture, and we want the full attention of the student. So we do not want to show anything on the student devices. Next, we prepare 2 questions. In this case, we ask for the course of study. In this case, for instance, computer science or media computer science, and also want to know why the students attend the lecture. If they are interested in the topic, or if they just want to pass the exam in this case. Next, we will try to connect these things together, and we will see this is not possible because we follow the concept of workflows. So we need an end fork in front of this, and now we are ready to connect these 4 things together, which will be the second step of our lecture. The third step of our lecture will be again a pause block in order to hold the first part of our lecture. And next we create a short learning question in order to check students' gained knowledge. And the special thing about learning questions is that you can mark a correct answer. And also we will set the answer feedback to true, which will reveal the correct answer on the student's devices. So they get a feedback whether this answer was correct or not. Of course, we could have further functions, but we just save it in this case. And now we are ready to execute this scenario. Therefore, I added another screen on the right where we have the student's perspective. And now we start our scenario. We press on participation details where we have the link in order to share with the students. I just input it on the right. And now the students can, can join this scenario. In the first step, we are in the starting block, which we saw earlier. And now we are in the pause block. So the functionality is in this case pause. So we can just introduce to the lecture. Next, we will unlock our 2 questions, which get visible to the students instantly. And you can now answer these questions as a student. And the lecturer will get an instant overview over the results of these questions, which are currently active. Now we finish these blocks again. In the next part of our lecture, the functionality is paused again. And now we have our learning question. And since we choose the answer feedback to true, we get a feedback whether this answer was correct or not. That's it for the short tool demonstration. We are currently investigating further components for our graphical editor in order to support the starting phase and also the modeling of complex scenarios. And the next steps will be that we evaluate our approach in real, traditional, or live stream lectures. And we want to extend it by further functionalities, further advanced functionalities, which will be presented by Dr. Urs Braun in the following. Thank you.
Okay, thank you very much. Are there any questions?
Oh, that's nice. Domain-oriented application of kind BPMN notation, I think. Did you use any workflow management system beyond your work?
Not yet, no. We just built on BPMN notation. So it's basically the BPMN JS editor, it's called so. And we oriented our meter model on their model. So we added a custom meter model to this in order to represent our audience response functionality or the back channel functionality and so on. So we have a large meter model which defines our functional scope of our system, and the editor just represents this in order to model these workflows.
Okay, thank you very much. And I guess this next paper is also from the same group, this time Iris Braun, presenting role-based group formations and interactions to foster collaborative learning in large classrooms.
So hello to everyone. I now want to present the poster here. Let me switch to show you this poster. Okay, I hope anybody can see it. Okay, so as Tommy said, we had an audience responses team that we can use for traditional classes at the university. But at the moment, because of the pandemic, we will have many virtual classes, and we can also have distributed classroom in other use cases. Maybe we have a worldwide distributed project team in large enterprises, and they want to work together or learn together. So collaboration or teamwork is an essential part in software engineering, and that's why it is also an important task in software engineering education. So we want to, so the students have to prepare to work in teams, and the best done is by learning in groups. So however, this is challenging in large software engineering classes, or it's more even in virtual classes. So we target to solve this problem by short-term group activities that we can introduce in this meta model of Tommy's work. So then the students can use their mobile devices to interact with the others in the group. Therefore, we extended the STARS audience response system with some collaborative learning tools. So we added 5 different group formation algorithms that take previous answers into account when forming the groups. So one example can be that you combine the worst and the best students in one group to support the knowledge transfer between the team members. Or we can form groups by their different interests in different topics, so which we asked before a group formation and such a survey question that Tommy showed in the meta model. Another use case should be the internal differentiation in large classes. So we can combine the worst students for the repetition of the missing knowledge, or the best students to give them additional tasks. To support the collaboration in the groups, we added 3 group interactions. So we added the textual chat in which the group members can exchange their opinions in a chat and discuss their group answers. Then we have a present group answer block so that we can show which answers the group members previously have chosen, and then a group voting where the group members vote together for a joint answer to the question. The implementation is based on the concept of roles, which allows a more intuitive implementation of different behavior for different user roles. For instance, the assignment of a moderator in a group voting if a joint answer was not found because we have a pet situation. With the role implementation, it's easier to change the roles within the class or in the group. For example, the lecturer can transfer the role of the presenter to one student of each group to present the results of the group interaction. Moreover, as the overall approach builds on the top of the meta model to define the functions and their parameters that Tommy showed in the video, the concept of roles allows the separate between data provided by the meta model and runtime data. An example for this is the assignment of students to a specific group, while the meta model only defines the number of groups or the group size. The assignment to the group is done at runtime. So our approach allows, for instance, to move the peer discussion as a teaching concept, peer instruction, in the virtual place. So in peer instruction, you have a first introduction to a topic, then you have some concept tests. And if the concept test is not so good, the students will grouped to each other and discuss their question and their answers, and then give a joint answer. So you can use our approach to make this didactical concept useful in virtual space. So it can be used in large classes if you have the problem of noisy group finding. If you remember, you have 500 students in a class, so it's not easy to form some groups in a room. So it would be better to have some virtual groups, and then you can use the chat or other things together to discuss this discussion. And this is also now used due to the pandemic, so that we have virtual classes at our university at all the time at the moment. Overall, we present an approach to create customized collaborative scenarios that could be used in software engineering classes or in virtual classes. We are currently investigating further use cases at the addition of an audio-video chat to let each group discuss in a separate Jitsi set, so that it's known as a breakout concept in other video conference systems, or the implementation of the jigsaw learning. This is also a common collaborative learning scenario. So at the end, I will thank you for your attention, and I'm looking forward to the discussion.
Okay, thank you very much. Are there any questions? Yeah, Peter.
So I see that you've modulated the group dynamics and group formation. Given that we've shifted from face-to-face, which was inherently synchronous, what are your thoughts about the asynchronous option? How important is that, or is that added value? Just your thoughts about the timing.
So at the moment, we support some synchronous scenarios, so like chat or video chat, or, but I think it's also possible to have some asynchronous parts, so that maybe the students work in a group together and present a result after 1 hour or so, and then they are in the groups working there together, and then it goes far in this in our workflow. But at the moment, the most of the workflows are more synchronously than asynchronous. So it's more thinking about in the class. So you can use it in a lecture of 90 minutes or so, but not about more than 1 day or so.
Perfect. Thank you.
Thank you. Okay, then I guess it's time for the next talk, although I'm not entirely sure if those people are here. So Soma Dada and Maruk Mirza, is anybody of you here? The paper focusing on both teaching agile software development and communication. Okay, then I guess we'll skip them. Then Takako Tanaka, Shinobu Saito, and Yoichi Kato, who of you is presenting?
Yes.
Okay, then so Takako Tanaka is presenting a poster on teaching machine learning, a vehicle towards introducing computing in, I kind of skipped a line. Do pipe cleaners help software engineers to understand agile mindset? The stage is yours.
Oh, hello everyone. Good afternoon. Today I talk about workshop-based learning course. To understand some important agile mindset with session of pipe cleaner arts. In our group, we have studied use agile method. We have studied use agile method a long time ago, but we saw the usage methodology was rather superficial in some cases. As a result, the development procedure was not efficient enough, and the quality of product was not expected. The main problem seemed to be in the developer's mindset. This was the motivation for us to start designing a course for developers to understand some of the most important mindset in agile methodology through real experience. I guess most have some experience to play with pipe cleaner when you were a kid. They are flexible, and you can cut, bend, and connect them easily with hand and needle nose pliers. We decided to use a procedure of making pipe cleaner arts in simulated system development procedures. Making it together with other participants is certainly fun. Thus, the experience of course would sink into the participant's mind. First, we defined the structure of pipe cleaner arts simulated 3 layers of system development: their system, function, and modules. And in the pipe cleaners, the system is wall canvas. Function is house, wood, mountain in the sample. And module are door and roof. In both developments, there are many participants. So they are collaborative effort of the team. In our course, main consists of 2 sessions. First session is intended with simple, less communication and only 1 development cycle. On the other hand, Second session is many communication and 3 development cycles. The specification is mainly the verbal description in the art of creative, including shape, color, and the relationship of part. The specification also includes the feeling atmospheres of art. The introduction includes how the developer communicates the development cycles, and total development time is same in both sessions. Each session about 2/3 planned development time. We have a sudden change in specification. This confuses the developer more or less and affects the quality of final products. There was a sample of participants' creation. In the reflection time, they compared the created art, discussed which is better, then discuss the reason why they're different. In this way, they are naturally recognize the importance of continuous communication among the team members and multiple development cycles. With this, and the course has been provided more than 200 NTT workers so far. We evaluate the course from the questionnaire given the participant after the course. Most of them found and said recognize the importance of communication and multiple development cycles. Also, many of them said this experience would improve the next development procedure. In conclusion, we think the course can provide a good experience for the participant to understand the importance of communication and multiple development cycles. This recognition through the actual experience will foster participant understanding one of the most important mindset agile methodologies, responding to change and following a plan. Thank you so much for listening.
Okay, thank you very much. Are there any questions?
So did you follow up? They're doing this game with actually doing agile development?
The follow-up is rather the further study. We have not done yet. We are now hearing what they are doing right now after they take courses.
Thank you.
Thank you for the question.
Okay, with those 200 people that you did the survey with, did those people have experience beforehand? Did you ask that, or was it more of you selected 200 random people and then just gave them the tasks?
So, could you repeat it again?
Those two, so you did a survey with 200 people, right? And did you also ask them about their prior background, like if they've had any kind of software development experience beforehand?
Yeah, we did. Most of the people only experienced the waterfall types of development. Some tried agile methodologies, but their view toward that methodology is not so good because probably the task was not so much suitable for the methodology, or they rather misunderstand what that means. I mean, the agile methodologies. So anyway, the participants are not so much well known about the agile before they take course.
Thank you very much. All right, so I guess we'll come to our last presentation for today. Stephen, the stage is yours on teaching machine learning, a vehicle towards introducing computing in undergraduate education.
Okay, thank you very much. Let's give it a shot. So I co-authored this work with my colleague from Butler University, Panos Linos. I'm from Rose-Hulman Institute. Our schools are fairly close by, and I originally did a sabbatical at Butler where Panos and I developed this machine learning course as an introduction to doing things with computer science for students who otherwise hadn't had a lot of programming. And so it was kind of ambitious in that regard. And we also wanted it to meet the needs of students who are computer science majors or software engineering majors. So on the teaser slide, I described some of the things we were trying to do here, like introduce computing into undergraduate education generally, using this as a tool to interest students in doing it, and bring software engineering to a wider audience that way. And one of the things we had in here was an ambitious project that that was an inherent part of the course. Here's the scaffolding to get there with each topic, say neural networks. They would start out reading about it and end up doing their own project of their own interest, whatever that was. Here's one student's work in a shared forum showing at the end of a week what they had done with it, for example. And so following in our theme of trying to appeal to a wide audience, we wanted really good feedback. So we designed a questionnaire into the course where they would say, like, how well they like different aspects of the course, much more detailed than what you get in a typical course evaluation. And we wanted to know in particular if our ambitious projects where they could pick their own project was a success or not, because you can imagine there were a lot of variations in that. We asked them as part of the course to help evaluate that, like what went well and what didn't in their projects. And then we surveyed the students with an actual questionnaire as well and asked them about these projects. Some of the feedback examples are here. We've had a lot of that detail now. At the time we submitted the poster, we only had one class, but we now had like many more, and we can grow our knowledge of this. They really responded by doing a good job on this survey. So I'd recommend this as a vehicle, that's much better than what you typically get in a standardized course evaluation at the end of a class, if you can address specific aspects of the course. And so we also asked the students to compare their work to other work, since it was semi-public in these forums, and they could see, how well they did on different algorithms and things like that. We felt that overall the non-CS majors were successful in this course, and it did interest them in computer science, and it helped infuse computer science concepts into other areas. In the future, we want to try a lot more things like this if we can. I'm not sure, what all the possibilities are. Perhaps some of you have suggestions you'd like to make, but that's basically what we did. So anybody have questions?
Okay, thank you. Yeah, there was one question.
Okay. So what is the basic knowledge that the student has before taking that course?
If they even had like a lot of them were engineers, if they had like a class in MATLAB, that actually worked. The course was taught in R, and we used packages for them to do the machine learning algorithms. So the main difficulty they had was like parsing the data, like converting data into different types and filling in missing data, and things like that happen in machine learning because the data sets aren't perfect.
So that means the before that course, most of the student has already knowledge of very basic things like linear algebra or that type of things.
Yeah, some of them, it wasn't a requirement, but a lot of them did have that.
I see. Thank you very much.
Okay, thank you very much. There's one more question by Peter.
This is just a variation on Cato's question. So if I'm teaching a survey course, what should I teach my students to help you? What would they need to know if they are non-computer science majors? What would be the one thing to emphasize if I had a chance to help people sort of carry on the baton later?
You mean what do the students need to know in order to be successful?
No, more accurately, what can someone in my position teaching a survey course for students that may eventually take your course, what would be the thing to emphasize to make your life easier as a prerequisite?
Oh, right. Yeah, just having familiarity with invoking software. In R, there's an environment called R Studio. It's like a lot of the other things that we use in computer science. And they write what look like command line things, but it's slightly more sophisticated than that. So if they had any experience using that kind of environment so they were comfortable with it, that would help.
Perfect, thank you.
Okay, thank you very much. So we've now had all presentations. I'm going to start creating breakout rooms in a second. I've already prepared them. So the way this works, I've created a breakout room for each of you. And then basically all of the other people can move in between breakout rooms and talk to the people. If there's currently no one in your specific breakout room, then feel free to just choose a different one and talk to other people there. Okay, any questions?
How do we get to the breakout rooms?
You will have received an invitation.
I see, thank you.
A quick question on decorum. So if we're in our breakout room, how do we balance visiting someone else's room and because I think a lot of people are presenters. So what's the best way to do this?
There should be a tab on the bottom, breakout rooms or something that you should be seeing somewhere. And I think you can just click on a different session and say join. Or you can come back to the main session if you don't know how to, and then I can assign you to a different room.
Okay, perfect, thank you.
Okay, you're welcome.
Strange, I don't see breakout rooms.
Okay. I mean, I haven't assigned you 3.
I can't see any. So, but normally I think Zoom should be configured in a way that everyone should be able to switch breakout rooms by now.
Mm-hmm.
Typically
Do you want me to assign you to like some specific rooms so you can check?
No,
or?
no, not really, because I'm one of the next presenters, so
okay.
I'm just in the session to see what's going on, but it just don't understand why because I'm also the one that provided the Zoom licenses, and I don't see how the breakout rooms work currently, and so I'm a little bit afraid of things going wrong.
Okay. Do you want me to give you host rights or?
No.
Okay.
I think it's okay. If you have them, everything is okay.
Okay.
Seems that we who are not presenters don't see any breakout rooms. Can that be true?
Okay. Then I don't know what the thing is. Then I'll just move you to a random session, okay?
Hello. I went to the breakout room for the pipe cleaners, and there I don't have a icon breakout room to move to other room.
Well,
okay.
I have a suggestion to to cope with that. We are rather few people, you know. Most of us are presenters, or most of you are presenters. So maybe we come everybody back to the main room, and then we open up the discussions for the particular posters, and then we have better audience, because I expected more people, you know. So
yeah,
we have the problem here with and we don't see the breakout rooms. And then we just if one person wants to go to one breakout rooms, we have to ask. So maybe it's better this way, so that everybody, you try to fetch everybody back here, and then you can communicate with each other. And well, we can listen. Would that be okay?
Yeah, that's fine. I already closed the rooms. So everybody should be back within a few seconds, I guess.
And then maybe you explain them what we're doing now. Sorry for that, but I think that's like an audience.
Okay, I think only Ben Reid is missing, but I think like the rooms are closing in 5 seconds, so he should be here with us in a second. Yeah, so we've decided that we were going to move everybody back because we don't have, we only have us as participants, so we can just talk, and if somebody wants to move into a breakout room, then I guess I can figure out how to restart them. Okay, should we just go through each paper and see if there's any more questions? Or does anybody have specific questions for a specific person or wants to talk to, I don't know, 2 people at the same time? Okay, we have a very active crowd today. That is fine. Okay, yeah, there's 2 raised hands.
All right, thank you very much. I have a question about the last session, last poster. Actually, I have a class in my university. I teach, in a sense, machine learning for the students who are not the, what do you call, the computer science. They are rather the machine environment, or what do you call, civil engineering, that type of people. So is there any, say, suggestion for teaching the machine learning or application of the machine learning to such students?
Yeah, this is Steve. When I was in college years ago, we didn't have a lot of computer science, but in math, there were suggestions like, why don't you just start out the students with something interesting like topology instead of all this, grilling on a year of calculus before they can do anything else and stuff like that. And of course, we mathematicians said, that's crazy. You can't do that. And I think the same feeling holds for something like machine learning. I mean, it is an advanced topic and you need a lot of skill in it in order to do it right. But I have civil engineers in my class and mechanical engineers and various other disciplines and people in the sciences. And my colleague at Butler has liberal arts students and pharmacy students and so on. And they tend to do pretty well in it because almost everybody has some basic knowledge of programming or, doing things like that, that they get somewhere along the way in their program. And they really are ready for a fairly straightforward approach to just invoking things that do these advanced, sorts of calculations like neural nets or things like that. And so I think you could be successful doing that, and you might try having a group of students who you run as a test to begin with and just see how it works, and tailor it to them initially and see how far down you have to go, in the scale of where do you start in order to appeal to them and to match where they are. But I think it's definitely worthwhile, and we've enjoyed some success doing this. It also, by the way, gives an advantage in that, to us, we believe probably everybody who's an undergraduate college student would benefit from knowing some useful little skill about software that they don't already have and might make them more employable, in fact. But, they don't realize that, and often their major departments don't agree with that, but it could help.
Just on the same topic, actually. So my view is that someone can learn more about computer science in 3 years than in 1. The problem is that if you teach it the traditional way, oftentimes people don't get to take more courses, because after the first year they hate it and they don't get the quick wins. And so what I've been playing with is the Amazon machine learning reinforcement learning model tool.
Yeah.
And it's that deep racer tool. And what's nice about it is that it allows students who are non-computer science specialists to get the quick wins, but to get really good at that, then you have to start diving deeper.
Yeah.
And so during the COVID situation, my school partnered with the school in Istanbul. Now I'm in Vancouver, they're in Istanbul, so the time difference was actually advantageous, because for us, we could do synchronous meetings on Fridays when it was 9 in the morning for us and it was 7 in the evening for them. So it allowed us to connect. But it was nice because you could train the models and students could see the success of their vehicle, but to get really good, they had to actually get good at calculus. So I had my grade 9 students start emailing the engineering prof who was available at our school. Hey, how do I do this? How do I do the calculus to get around the track? And all of a sudden they could understand the applications of the mathematics that they were learning or about to learn. And I think that engagement, those quick wins are really important. And plus, this didn't require a computer lab, which feeds well into our cloud first infrastructure.
Yeah, thank you very much, both guys, Steve and Peter.
I've got a question for Ben, actually. Like the Raspberry Pi setup that he has running is genius because it's so low cost and just so accessible. Anything else that you've done? Like this is such a short session, so we couldn't talk about everything, but anything else that you're doing that's really accessible and innovative like that?
Not really. I mean, I've done actually, I'm a big fan of, I think a lot of people that use Raspberry Pis are really big fans of Raspberry Pis. So I do have other projects going on. Like I teach the operating systems class, and I'm teaching the intro to hardware class next semester, which uses machine language. I'll be teaching that in x86. But the cool thing about the Raspberry Pi is you can start teaching ARM assembly, which is kind of nice because there's a lot of ARM devices out there, and there's a Mac coming out now with ARM. So it's kind of cool both in the sense that you have these ultra cheap servers that are just so inexpensive. And you also have another hardware architecture that your students can work with, which is also very cool. And they really are very capable machines. I mean, and the other cool thing is they do power over Ethernet. And so as far as maintenance wise, it's one wire that connects the Pi, and it gets power and everything through it. So it makes it nice to manage and to use. Yeah. So one thing I did learn, I went cheap. I really do have a small budget. So I went really cheap on my first round, and the first set of Pis, I saved $10 by buying these like splitters that does the power over Ethernet, but it splits it out into like a USB and to an Ethernet connection. So you have two connections that go into the Pi. So it's $10 instead of $20 for the little hardware device that connects to the Pi. That $10, totally worth it. I mean, I ended up getting rid of those because it was just too problematic. I mean, there were, the wires would get loose and stuff. So, but I'm really happy. I mean, there are a couple of other hardware projects we're doing with Raspberry Pis, and it's just really nice to have this server that you can dedicate to a student that's under $100. It's really quite amazing. And I should mention, I was going to mention this in the poster session. One thing that I found is very cool about the Raspberry Pis is that they're buggy. And while buggy can be frustrating, one of the crazy things, because I've been keeping track of this, I've never had a student complain about the bug. Like, they have to work around it. Like, the DHCP requests that come back, they're wrong and they don't follow the protocol correctly. And when they do TFTP, they don't do that consistently either. Sometimes you have to have some options and sometimes it works without others. So they have all these bugs they have to work around and it makes their life hard, which is good because I want them to get this real world experience. But the crazy thing is they'll spend like many, many nights and many hours trying to work around these bugs. And no student has ever complained to me about the bug, which I find just so fascinating because, you know, if as instructors, like if we create a simulation environment for our students and there's a bug, you'll hear complaints. Rate My Professor will be like full of comments about how crappy your code is. But you know, if it's something real, then somehow, you know, but they realize bugs are there, and so I thought that was a really fascinating result.
I love the what is it? Behavior engineering. That's part of the software engineering.
Yeah,
Nicely
right.
done.
So before you, Ben, before you talked about that you only had 4 people per group, is there like a specific way in how you assign them, like based on, I don't know, prior knowledge or?
No, you know, that's a great question because so I actually came from Facebook to San Jose State. And I had worked there many years, actually. I'd worked in industry many years at different companies. And so I did like this survey of alumni and I said, hey, what do you wish you would have learned, right? And there were 2 things that, well, there were multiple things that came out, but 2 that I really applied to this course was, you know, computer science is very collaborative. I mean, you know, oftentimes there's this nerd in the corner kind of thing, but that's not usually, I mean, there are cases of it, but usually it's like people collaborating like crazy. And you're collaborating with whoever you end up when you get hired, right? And the other thing that surprised students was they don't develop their own code. I mean, especially when you're entry level, you're like told, hey, look, there's this pile of code over here that nobody knows how it works, and we've been meaning to fix. You go over there and fix it, right? So you don't work on your own code. And so what I do is we're on semesters. So I randomly assign a group. Everybody's randomly assigned to a group, and then I reshuffle 2 other times. So they get to work with different random groups of people, and they move to a new group and they can't take their code with them. So it's kind of like they're moving to a different company. So I found when I started with 6, I found that the ability to slack off was too high. I mean, I would end up with 3 students that were doing all the work and 3 students that were just slacking off, right? So I think 4 I found to be kind of a really nice number because
sorry to butt in there, like how did you know that those 3 other students or 2 students or how many per group who weren't doing any work, how did you know that they weren't doing any work? Because like usually on an instructor level, that's like kind of hard to notice sometimes.
Oh, I have them do self-reviews at the end of each phase, right? And I hear complaints from their group mates. So with those 2 pieces of data, I could kind of construct a pretty good view of what's going on. Yeah, so with 4, I found that, because I do give them substantial projects to work on, you know, in each phase. And I found with 4, you can kind of divide and conquer, and then you can do pair programming. So it's kind of nice. And also with 4, you can have one person that slacks off. and the group can still have success, you know? So yeah, so I found that to be a magic number. I don't know how universally magical it is, but that's kind of what I've settled on.
Okay, thank you. I have another question to the pipe cleaning crew. Was there anything else along those lines, like something like very hands-on and arts and crafty that you've done before? Or did you just think like, oh, pipe cleaners are like a cool thing to demonstrate processes?
Let me ask that. Let me clarify that in Japanese a little bit. パイプクリーナーに行き着く前に何か他のものを試してみた？
あ、試しました。
何やった？
ペーパー&クレイ。
はい。
紙と粘土。ペーパー&クレイ。ペーパー&クレイ。
Yeah, maybe you get it. Paperwork and clay. It's you can make three-dimensional things out of the clay, right? And the paper, what did you make for the paper?
I think it is origami paper.
I see. Origami, probably you know the paper foldings. Do you know that? Paper foldings, like we can make like a clay or that type of things. That's sort of Japanese kit work. Then we end up with the pipe cleaners.
Okay. Was there, okay, so like I personally do a lot of arts and crafts, and like I've never had any issues there, but I know a lot of people, especially from, you know, if you think back to high school and whenever arts class, like there were a lot of people with like a lot of reservations against working and doing things with your hands. Did you experience that as well? Or was there something specific that you established to basically take the, I don't know, fear of being creative away?
It looks like that almost most of the people had some experience using the pipe cleaners in before. It's a very popular, say, kids what they play. Probably you are in a 9 or 10. When you are in elementary school, so they jumped in to make something they are ordered, like a house or the home or the mountain or landscape, such things, and they are really enjoying doing so. And that was really nice for the training because it was enjoyable. That's probably the most thing that the course was very successful.
Okay, thank you. Is there any, okay, Peter, you have a question?
Yeah, I have a question for Tommy and Iris and the collaborative learning group. I just love, like, I've never actually come across literature that dissected group formation. And so I was laughing at the best to worst groupings and all those strategies. So could you speak more about your experience? Just as I work in survey courses with my students and I'm dealing with people who are a broad section, these aren't necessarily enthusiasts of computer science. There's some people, especially in high school, where their parents told them they were taking computer science. And that's just the way it is, and they didn't choose it. So you have different levels of ability and different levels of enthusiasm. And so I was wondering about what would you suggest, especially for survey courses or undergraduate early courses, what kind of group formation would you recommend? What are your thoughts and experiences?
So I made the experience in my last practical works. I teaching service and cloud computing. So it's not undergraduated, it's more in the master thesis or diploma degree. And there it's very interesting to see if you mix the people that are very experienced with the people that are not so experienced in software development. So the people that are not so experienced, they can learn many from the others. But the problem might be that this one that have no knowledge or not that good knowledge will do nothing, and the other will do the whole work. So that's the other experience we had. So then we mixed the groups with students that have maybe the same level of experiences. And then these groups performed really, really good. So they have very interesting projects. And the others that are not so good, they also learn from each other and they have to do the practical work more by themselves. And I think so they learned more if they are in a group with the others that are not so experienced. If they are in a group with the good people, then they can see how the others do it, but they learn it not by themselves, by doing it by themselves. So the experience in the practical courses was that it might be better to have groups with people that have the same experience level in software engineering, and then their results are not so good at the end, but they learn more by themselves to do it in practical. And that's it's in our classes, it's very important that they do it in practical work by themselves, and not only to learn about the concepts and the theories and the definitions, but do it by themselves, practical.
Iris, I completely agree with you. That's been my experience as well. So across all levels, there's a bit of a trade-off, because I think perhaps if you're looking for just the outcome of the project, maybe the best to worst pairing or even random has a superior final outcome. But the problem is that the students involved in the group, if they're not capable of contributing, they don't learn at all. And so I would rather have everyone learn a little bit than have only the hardest working and most experienced do all the project, and the other people not do anything. So I totally agree with you. And it's funny how this experience matches from master's to undergraduate, even to secondary school. So thank you.
Mm-hmm.
Okay, thank you.
I have a question to all of you. When you are looking at your titles or the content of your papers, it's about floating satellites, it's about network management, and it's about machine learning. And as most of you will know from the reviews you got, there is a discussion ongoing that this is software engineering research. In the end, and many people, and it was discussed on the program committee, whether this is really something CC should care about. And in the end, Elke and I decided, okay, these are not papers that are maybe addressing how to teach software engineering, but it's stuff a software engineer should care about, or a software engineering student should care about. And so it would be nice to have why you think that this is important for software engineering education.
So I can start. I think for me, actually coming from industry, one of the big emerging areas is SRE, service release engineering. Okay, there's various acronyms for SRE or meanings for SRE. But certainly, and there's DevOps, and all that comes back to manageability and understanding what's going on in the network. So for me, management and network management and understanding those concepts is, it's something that every software engineer, okay, I guess there is this definition you got to work out about what an engineer is, right? But to me, the difference between a scientist and engineer is that an engineer builds, right? A scientist researches, an engineer builds. Now, that's probably an oversimplification, and maybe not everybody agrees with that, but in order to, and so that's what my work focuses on, is teaching people how to build.
Well, we've had some good discussions about this in past CSEET conferences, including interesting questions like half of the time you spend in software development and industry is testing. So why isn't half the curriculum testing? There's most people can get out of a computer science program without ever having any courses in testing, right? And things like that are just, they sound crazy. Like, all of our programs came out of the math department. So will they forever be like math because that's where they came from? even though, as you're saying, the need is for very practical skills like DevOps and things like that to go with this. In the area that I was talking about in data mining and machine learning, you get people with titles like feature engineer, and they may be responsible for like one column in a matrix to make that as good as they can get it in order to make the predictions of the machine learning system as good as possible. So it seems like, we could have a fairly broad breadth of things that really are still at the heart of software engineering.
Can I just add one thing? I am new to education, so I completely defer to you all as to what is appropriate for the conference. I mean, I didn't feel offended at all about any of the comments I got back. So this is just my perspective.
Perhaps it's a little bit a matter of size. If you see how practical systems, how big they are, and what you have to consider compared to, the small toy projects that you do at university, I think a size difference of factor 5 changes everything. And most of the systems that we have in the industry to deal with are in the millions of lines of code. So I think different approaches for different kind of tasks are necessary. And for example, to just keep the knowledge, keep the ability to change a system, a complex system needs different things. So that's, I think, the reason, Ben, why testing is so much used in industry and not at all, or not a lot in universities, in academia, because they are not necessary, because the systems are not big enough. It doesn't matter really, because you can understand nearly everything in a toy project, I would say. One person can have about 80,000 lines of code in their head quite well. And after that, you need a team and multiple people and a completely different way of working. I think that's one of the major changes between university academia and really big, long-running products, not projects, because it's not projects.
I'll chime in on that. So I've been a part of the Chief Information Officer Association of Canada for nearly 20 years now. And when I started, it was, what can I learn from the person at the lumber mill or at the bank in IT? And now that I've been part of it for so long, I'm realizing that it's really hard for one to find a list of things that are exclusively your problem or your consideration. And I think with IT and software engineering, I think the more exposure you have, the broader the conference, the more people realize that this niche skill set is transferable to that other area. And so I think just a broader tent for the conference is wise, because each year you'll get different people with different specialties. And then depending on the quality of the papers you get, maybe you divide streams up thematically. But I like what you've done, where it's just a broad catchment, and we clearly have found commonality, even though we're in different parts of the region, different levels of education, different specialties. So I kind of like what you've done, and I wouldn't modify it too much going forward.
Arian, do you want to say anything about that yourself, like for asking the question?
Yes, just thank you for all this opinion. This was basically also what Elke and I had in mind when we were faced with this discussion on the PC, that it's software engineering, or that teaching software engineers is not only about the classical software engineering lectures, but that there should be a broader scope, that students shouldn't need to look to the left and to the right and stuff like this. And Yes, thank you very much for your opinions. We are still gathering opinions on this.
Yes,
Okay,
and we think that in software engineering, when we try to solve problems, we solve problems in other domains. So students should be able to try to understand other domains, whether it is in their studies or afterwards in their jobs. So they have always to learn new things and things which are not out of their profession. They have to understand the problems of others.
But isn't that life?
Yeah, that's life, and we are training students for life.
And especially, there's so much software out there already. Just to maintain that is nearly impossible, I would say. So we will have lots of software architecture that will be then software ecology. I hope I pronounce it correctly. Software Archäologie for the Germans. And that is so much effort that we will all have to deal with that. And we have to, that's what would be something where I would like to see some more research and some more papers about how we will work on that, because otherwise we'll have a bad reputation in society. Because it's our responsibility to maintain our own stuff.
Okay, I think Ben wanted to add something on.
Yeah. If I could just add a little bit, I do think, okay, I'm the worst tester in the world. I'll say that right up front. But I do think testing is super important, and I also think we could do it at school, in academia, because in the end, oftentimes, even though you do have like hundreds of thousands of lines of code, usually bugs manifest themselves. Not always. Sometimes bugs are very, big and systematic and things, but oftentimes the bugs that really bite you come up in little sections of code. And I look at the simple programs my students write, and they turn it in, and they always want to get full credit for it. And I'm looking at it and I'm like, wait, you're not even testing the edge cases, right? And they're like, but your examples, they didn't test those edge. And I'm like, oh man, you guys really need to learn how to test code. I do also think there's another area that I think is super important to explore that I'm also not very good at, which is ethics. And in all our engineering organizations, there are ethics aspects to it. And especially nowadays in computer science, the fact that we've ignored ethics has caused us untold headaches, right? I mean, even today, a lot of, I see these arguments, criticisms against the big tech companies, like on many dimensions, and they're conflicting. And I think part of it is, as engineers, I shouldn't say as engineers, there's plenty of engineering disciplines that have very solid understanding of ethics, but I don't believe that computer science does. And I think a lot of that starts with education. So I don't know, has that historically been a focus of this conference, or an aspect of this conference? The ethics dimension?
Peter?
I'd like to sort of, I can't speak to the history of the conference, but I would actually flip that problem and reverse the order. I think, so ethics are clearly important, but I also think that computer science is getting sometimes tarred with a bad name as, oh, the algorithms are evil or they're unethical. And oftentimes in machine learning, it's a data set problem, and not that the algorithm itself is biased. Like the data, if the data reveals an uncomfortable truth, then and if society understands how machine learning and algorithms work and artificial intelligence works, then I think you have an opportunity for people to reflect rather than sort of having this magical perception of computer science as either being ethical or evil. And so I think you have to walk with both the left and the right leg going forward. And I think ethical understanding by computer scientists is important, but also the general public needs to understand computer science as well, so that they don't have a false understanding of what computer science is, and that it is somehow inherently ethical or unethical. It just reveals data. Those are my thoughts.
So I agree with you. And I think that's one of the problems that we've had, is that as computer science, as we make these advances, and we've made them very fast in computer science, we just think each advance is good. Like I still do deep down inside, right? I mean, we connect the world. That's awesome, right? We make computers faster. That's better. We get computers into the hands of more people. That's like objectively better. But is it? I mean, have we really? I mean, I think part of the reason some of these things came up with machine learning is we just didn't think of it. I mean, you're right about, it's the data and it's what we're putting in. But, we really should have thought about it first instead of reacted to the problem later. And I wish I was taught that. Okay, now I'll blame my teachers. I wish I was taught that so that I could teach my students, because right now I'm just trying to catch up, and I'm trying to figure out ways to teach my students ethics so that they can just kind of see these problems going forward. Because I look at other disciplines and they already had these review boards, and they already, like chemistry, they know that when they do certain types of experiments, they need to think about some things. But I mean, computer science, we're just starting to get that. And I think that's, I think that's, we're missing it.
I like this conference because it's super technical, and so I live in the educational technology space, and so I have an abundance of conferences that are in the social sciences, humanities, where my stuff is a little bit too technical, and then of course I have the technical space where which I love, where you get to talk about the computer science discipline more purely, and I think maybe the challenge for us is then to take our expertise and visit those social science humanities conferences and share our expertise there. I kind of like the purity and the technical nature of this one. So that's my sort of 2 cents, but I'm a, sample size of n equals 1, right? So, what do I know?
Well, I think there is an issue that some of you are suggesting, that our technologies and our science we're like the new kids on the block, and we're going to stumble into mistakes that other people have made in the past in other fields, and maybe we should be learning from them. I mean, we're often analogized to Gutenberg inventing the printing press, and he thought it was going to be for great books like the Bible, and 15 minutes later there were people banging out political pamphlets in the back room, right? And we're kind of in that boat with Gutenberg, I think. And maybe we just need more experience and know how to incorporate the ethics in and some of these other social values, so that our students learn these along with all the good technical stuff.
Yes, just when we are talking about ethics, I think about 2 aspects. One thing is we might have unethical algorithms, or algorithms that are not so fair, I'll put it this way. On the other hand, we have the problem that we increase social problems. We develop programs that increase problems that are out there in the society. And you might say that this is not in the first place the problem of the guy that builds the system or builds the software, because the problem roots deeper. But I think it's still some responsibility that you or students should know what the impact will be if they work on these things and basically increase such society problems.
So I think that the idea of making sure we cover ethics more in education is quite complex, because a lot of people who are supposed to be teaching this kind of stuff still don't understand ethics well enough. It's a wide-reaching problem. So if we collectively, as individuals, I'm going to assume that you're all perfect with ethics, but collectively, the wider industry, we just don't know what's going on. So how can we then pass that on to the others? But then it's also more than just the ethics of the technologies. If we're going to talk about ethics of algorithms, that's one thing, but what about the ethics of software engineering, project management, and things like this? There's a whole other raft of ethical issues that are strongly tied to this, but are already questioned and answered to some degree in other areas. You know, if your boss says we're going to look at X, it seems reasonable enough, but actually it might, it doesn't sit well with you. Do you feel comfortable with saying, no, I'm not going to do that? And that's not a computing thing, but we don't necessarily do that. So it's a much broader picture.
Okay, thank you for that comment. Apparently there's nothing that anybody else wants to add. From my experience, like we do a lot of student projects that aren't necessarily just toy projects. Like we have real people from the industry coming with like real problems, and we develop apps that they are essentially using, even if it's just like a prototype, but they're using them. And we also have a lot of people from different fields. Like we have computer scientists, we have business people, we have people from games engineering, people from, actually now we also have people from sports and health management who have absolutely no programming experience. And usually those people come in are like, oh, like I don't even know what to do here. I can code, I don't know how to do things, but they add like a very valuable asset to the whole group because they have a very different perspective. And then like the students also start to learn to see things from a different perspective. And I think that's like the most important thing, to like keep the conversation between different fields going, and to actually ask for help or input. Because I think that's like a main thing that's a little bit missing in general education, that some people just don't ask for help enough or for feedback enough and aren't willing to accept the feedback in a way. Yeah. Okay. There was one more thing that I meant to ask way earlier before this whole discussion. So if anybody has to add something to that discussion, please do that now. Otherwise, I'll ask my other question. Okay, Muhammad, you're kind of like very quiet there in the corner. I meant to ask you, so in your paper about your really cool space simulation, you said that you train bachelor's and master's students to do like different control algorithms. I mean, this goes kind of back to the discussion that we just had, like how do you test that? Do you have like specific, like a test suite? Do you just look over each person's code?
So actually we provide the student this float set as a platform to test the attitude control algorithm what they develop. I mean, there are different control strategies already there and which one they are adopting for different missions. So before that, I mean, we don't have any kind of thing in the lab for the aerospace information technology students. So we provide them a platform, and on this platform, they have been given a task first to develop the float set like the one what we have seen, and according to the mission, design the control algorithm. So this is the task that we give to them, and then all the basic satellite subsystem is already available on the float set. And we provide them this platform to write and test the different control algorithm strategies, develop new ideas, algorithms for the purpose or the mission of the satellite, what they have as their project. So this is the purpose of testing. That means that we provide a platform to them to do the further experiment for their control algorithms.
Maybe I missed that earlier, but what kind of background do your students have?
Actually, as you see, that as I've explained, this float set we have developed for the team design project, where we have at least one mechanical engineer who is responsible for the construction of the float set. And then we have also one person who is responsible for electronics, for the interfacing of the different electronic component and also all the connections. And then we have also one embedded system developer who is responsible for writing the code and also the ground station. So for all the float set project, we have every time this kind of multidisciplinary group where people combine together and then form a group where the mechanical designer can also work as the supporter for the developing the control algorithms. And we can also have the other people or simply a guy completely from the control background. So this was actually the float set was part of a Erasmus program in Europe, where we have 3-4 universities. They also contributed for last 10 years for this Erasmus Masters program, where we have international students coming from different disciplines like mechanical, electronics, electrical, and sometimes we have the people from the geography background. So in this project, we also had the people from the geographical, the people from the background of geography. So these kind of people with different backgrounds participate in this project and try to work in the team and do something for the education in the space sector.
Okay, thank you very much. Are there any other questions, thoughts? Okay, so I think the next session is starting in 20 minutes. So I would just take this time for a break. I mean, whoever wants to can stay in the Zoom room and keep talking. Otherwise, thank you, everybody. Also, thank you for constantly muting yourselves and for raising your hands first before asking a question. I think this was like the best session I've ever moderated with like the best behavior.
The ethics
Okay.
were very good.
Come to the next session. It's really worth it.
Okay, do you want to take this time for a little ad why to come to the next session?
Because it reflects our view on lifelong learning and what we do at the industry. So I hope it's interesting for all of you.
Okay, thank you.
Thank you. Well done, everybody.
Yeah.
See
Bye.
you. Bye.
Thank you. Bye.
Thank you very much. Good night.
Ja, war doch ganz gut, oder? Du bist gemutet, Elke.
Sorry.
Auch.
Was ich nicht geschafft habe, ist mir ist nicht klar, wie die Aufzeichnung läuft, weil die kriege ich so natürlich nicht gestartet.
Die läuft aber noch, ne?
Oder ja, doch, ich habe sie gestartet, genau, aber ob sie tut, weiß ich nicht.
Du bist gemutet, Elke.
Sorry.
Also bei mir läuft was, aber
Auch.
jetzt.
Was ich noch geschafft habe.
Ich glaube, das läuft.
Okay, gut, wunderbar.
Cool.
Gerd, magst du mir für den Fall der Fälle auch noch Co-Host-Rechte geben? Ich bin ja offiziell der Session-Chair hier sozusagen. Ich würde dich dann auch kurz ankündigen.
Aber natürlich gerne. So, ich muss nur erstmal hier, ich habe gerade Pause gemacht auf dem YouTube, weil es sonst von den so, Stefan, Co-Host erstellen. Co-Host erstellen. So, das müsstest du jetzt sein, oder?
Super, danke. Dann kann ich notfalls auch noch
Eingreifen.
Ja, genau. Perfekt.
Dann würde ich nochmal jetzt genau von Anfang an wiedergeben. Dann würde ich das Screen Sharing nochmal starten, dass jeder weiß, dass er richtig ist. Und zwar den Desktop 3. Das müsste jetzt wieder gehen und ich sehe euch. Das heißt, Timothy is already there. Cool. Hi, Timothy.
Hello, how are you?
A little bit, how can I say? I haven't done so many presentations in English as probably you. So for me, it will be the first English presentation in years.
Yeah, you know what's the problem that I have right now is that this conference was delayed from July, and I had already another conference this week, which I'm presenting at. So I actually have, starting at 4 o'clock in the morning, this conference, and then another conference that is starting now, and
wow,
and so I have 2 overlapping conferences, and I can't get out of them because I have presentations in both.
Yeah, but for example, our presentation, as everything is recorded, I think it's you're a little bit more flexible.
It's the same in the other, so yeah. But yeah, this is an exhausting week. So, but if I was doing it in another language, if I was doing it in French, which is my second language, it would be just doubly exhausting. So I get it.
Yeah. It's funny that in Germany, most of the company internal stuff is in German.
Well, you would expect that.
So 2.5 minutes to go. Andreas is joining as well. He's also a colleague. And Stefan, everything okay with the conference for you?
Yeah, I think it works really well.
The socializing part is a little bit missing.
Yes, this could be a little bit better, but I guess people are jumping in, jumping out, and have other meetings as well. So I guess it's okay.
It's like the positive and the negative aspect of remote conferences is that you can selectively join and leave the conference if you want, but people are doing that, so it's hard to network. Yeah, I'm just joining to listen what my colleagues have to say.
Hopefully you agree with what we want to say.
I'm sure.
If not, just interrupt us, as hopefully everyone else. So if you have questions, just ask.
But I think the SE Games workshop is also very popular. So let's see how many viewers we will get.
Yeah. So currently 8 people.
What do you think? Should we wait a few more minutes until more people join, or do we want to start on time?
Perhaps 1 minute after the hour.
Okay.
Because at least at TNG, we are really punctual to the second with meetings, but I don't think this is always the case in conferences.
You're a real German company.
It's so much easier if everyone is on time. So you don't have to think about it. It's just the default. Everyone can read the clock and it's easy.
I guess more people are joining right now.
Mm-hmm. Already 10. 11. Ben joined, yes.
Hey, everyone.
Hey.
So I think it's 1 minute past 4, and we'll do a slow start, I would say.
Okay, yeah. So welcome everyone. I'm the session chair of the industry session, and it's my real pleasure to introduce to you our two speakers, Gerhard and Franziska, both from the company TE, who also provide the infrastructure for this conference. And it's really amazing how well it works, in my opinion. Thank you for that, first of all. And now, please tell us more about lifelong learning in your company. We are all eager to hear more about this.
Thank you, Stefan. I think you recognized the sound already. So welcome to our talk about an industry point of view, software engineering and lifelong learning.
So what are we going to present you today in this talk? So first, we will give you some context and background information so you can better understand our point of view. Then we will talk about our main 5 topics: the people, process, technology, scaling experience, and we want to articulate some wishes how software engineers should be prepared for the industry. So a few words about the company we are from, TNG Technology Consulting.
So why is TNG existing? We solve hard IT problems with cool people. The company was founded to have a company in which you want to work yourself. Headquarter is in Munich, but we operate in Munich, Augsburg, and some other places. Where does TNG stand for? The nerd group? Probably yes. Or the next generation? We think both. Then you can understand why we choose to show you the Starship Enterprise from Star Trek TNG. We want to create always at the frontier of technology, and sometimes do things not because it's possible, because it's sensible, but possible. What do? We do agile software development nearly from the start of the company, artificial intelligence, DevOps, and cloud. Some numbers. We started at January 1st and in 2001, so we are nearly 20 years old. We have now 462 permanent employees. We will make about 60 million euros in revenue this year. And we have, except one cool colleague, everyone has a university degree, and about 60% do have a PhD or similar. And that's something that really distinguishes us a bit, because we think that smart people can create more value than many normal people. So a little bit like universities also. Some words about what is an IT consulting company. Everyone works typically for several years, so 2 to 4 years in one project context. About 50% of our projects are at the customer side, mostly currently in around Munich. We used to travel mainly for going to conferences, not because of clients, but because of the conferences. Sometimes we do have TNG only teams, sometimes mixed teams with employees of clients and other consultancies. Fluctuation rate is about 4 to 6% per year, so quite low in our experience. for the presentation. If you have any questions, just please ask and interrupt us. So, who are we at TNG?
So my name is Franziska Steinecker. I have a bachelor in computer science from the LMU, and I also finished the training to become a teacher in computer science and mathematics. That's why I also have an exam in psychology and didactics. I joined TNG 4 years ago as a working student, and I am now working full-time as a software consultant since 2 years. I'm highly interested in our learning setup, also because of my background, and I participate in workshops, talks, and the training for our new colleagues. I'm always trying to improve our learning culture. So I hope I can give you some good insights on how we are dealing with learning in our company.
So I'm Gerhard. I studied computer science at the Technical University of Munich. And I also had the pleasure of working with Bernd Brügge in my last year where I did really my studies. And I've been with the Erasmus Exchange Program in Newcastle upon Tyne. I'm also one of the founders of TNG Technology Consulting. I also founded several user groups here in Munich. For example, the Atlassian user group, Design Thinking, Software Architecture, and perhaps we are going to found the Slack user group in the next few days. I'm one of the drivers at TNG at how new colleagues are trained and onboarded, and I'm thinking a lot about organization, structure, feedback loops, and all that. So, what is the most important thing at TNG? The people.
So which kind of people do we work with internally and outside? So our colleagues at TNG are, of course, software engineers, but also a lot of career changers. For example, mathematicians and physicists. So actually, they are even more than the software engineers. And there are still lots of other people. We have other engineers, psychologists, former teachers, and a whole bunch of people with different backgrounds. Where else do we get influences from? So for example, we have a lot of influences of young people from university. Lots of colleagues join us directly after their doctorate, master, or bachelor. And we have a lot of influences from our customers, because we work together with colleagues from there, and that often on a daily basis. So what's necessary for becoming a colleague at TNG?
So, as already said in the introduction of TNG, we have highly complex problems to solve. And this is done best with people who have an analytical thinking, are very disciplined, and have a really bright mind. Sometimes we use the saying, great CPUs, and we are able then to load the software, the concrete knowledge, onto these bright minds. As said, often people direct from university, so they don't have to unlearn a lot of stuff.
So why are we not only hiring software engineers? One very good reason is there are just not enough, especially in big cities like Munich. And we also have to work together often with people from business, also from the customers. We sometimes even need to explain what's necessary on developing individual software. So we need people who explain and sell our skills to the customer. Then the career changers actually offer a great diversity. And people coming from physics sometimes need realignment because not everyone can work in research, and they are very welcome to join us. And what's also quite important are the psychologists. They are very important for our team and team dynamics. For example, the best Scrum Master at my customer is a former educator in kindergarten. So even such career changers are very welcome. So how do we work and learn together? What are our processes? What actually helps us to organize our learning and working at TNG? What's really quite essential in our daily work is the teamwork, and it's really part of the daily business. Agile is standard in our company, so we are working in a group of 7 people max usually. But why are we actually doing it? because almost all relevant problems in the world can only be solved in a team. So good team dynamics and a good team spirit is essential for us. And maybe that should even have some more impact on research for software engineers. We do pair and mob programming really a lot because it helps us getting productive fast, even on starting as a newbie, and it's actually the preferred way of working. One good reason is it synchronizes the mental models of all team members, and it speeds up learning as it includes direct feedback of your teammates. So, what other feedback mechanisms do we have at TNG?
So the real aim of the game is that we are continuous experimenting and learning on all levels. This is the key for long-term success in our opinion. And I'll give you some examples. On the personal level, what we really encourage, what we really try to do is doing regular one-on-ones. So typically every 2 weeks with a more senior colleague, that's the norm. We send out small info nuggets. So we are nudging our colleagues with small emails that say, try that, this is how you take a vacation, do this or try that. And this is also something we developed on our own. We do regular tech days. We'll go to that in a little bit more detail later. And of course, you have annual feedback talks that in other companies would be personal evaluation meetings, but we are not really evaluating and giving grades, but try that as a kind of retrospective and looking in the future, what would suit your needs. On the project level, we do a lot of test-driven development. So this is absolutely the standard. We do that typically with pairing and, like Franziska said, mob programming. We have the typical dailies that are the norm in agile software development. We do story reviews. We do, of course, continuous integration. We have a Scrum retro every 2 weeks, or what depends on the project, the length of the iterations. We do release retros and also project retreats at least once a year. And on the organizational level, we do yearly summer retreats, and we have done that in the form of open space conferences the last 10 years or something. So where you really are together and discussing things that come up from the colleagues. It's not from the management, it's really from the people at the company. So if you really want that people do learn a lot, give them time for that learning. So give them explicit time. And this is what we do with tech days. Tech days are something we invented a lot of, I think, 18 years ago. And what we do is every colleague has 2 Fridays in a month. Because the company is a little too big for our rooms, we have the first and third Friday or second and fourth Friday in a month, where you don't work for the customers, where you really come into the office before the pandemic, and where you really have the time to do what you decide to do. What we typically do is we have a 2-track conference program. We have lots of workshops, lots of reading groups. We sit on the terrace and grill, eat a lot of meat and vegetarian stuff, and have really time to mingle and to connect to each other. On these tech days, there's typically no work for clients.
So, what are different training opportunities we have on such tech days? So, for example, there are lectures, reading groups, workshops. You can contribute to open source. You can invest your time in networking and exchange with colleagues. And you can also give a training to other colleagues. So it's your learning by teaching. So I hope it's easy to see that we actually try to provide offers for every level of software engineer, from a newbie up to the senior who joined 10 years ago. And we have really a lot of different types of trainings. So you can focus on your software engineering skills in our Mastering Software Development track, Or you can focus on your personal development and your soft skills, for example, in the mastering consulting skill track. And we have a lot of other things which are not now yet in some tracks. So we also hope that whatever suits you the most, you will find a little bit in our training offer. What you need for it is actually some self-regulated learning. It's a lot of freedom we have, and with that comes a lot of responsibility to use it, use the time we get, use the offers, and to make the best out of it. And of course, to also give something back. If you have some knowledge from your project, then take the chance, try to give that knowledge to some of your colleagues and do a workshop or a lecture. And this actually also offers some outside of the box learning. It's not only about things which are relevant for your current project, but also things where you're just simply interested in, what you always wanted to try out, or where you just want to test it on your own. So what helps us working together?
Yeah, that's technology, what helps us to learn and work together. And therefore, you have to organize knowledge a bit, because that's what in the long run is really helpful. And what is that is the most important part of that is, again, the colleagues. Multiple colleagues on varied projects with different backgrounds. This is extremely stimulating. All this exchange at tech days, workshops, etc. What we also offer, of course, is a big broad offer of training opportunities with talks and workshops and reading groups, but also including external speakers or going to conferences or external trainings. Everyone can just buy books at TNG, and there's no process that hinders that every book is just bought on the same day. We experiment a lot. For example, currently we are evaluating Pluralsight. It's a learning platform. And also we organize and host a lot of meetups and user groups at our rooms. Currently not, but typically. And also what is important is who knows what and who can trust whom. And for that, you need to know the people. So we have a profile per employee. You can see that here on the left side, that everyone fills out. So you can search for people with a certain knowledge and then really connect and mingle. So trust is, in our experience, a big catalysator of working together, and of course, a culture of helping each other.
Technical knowledge actually evolves incredibly fast. And at least in my opinion, front-end frameworks seem to be even the fastest on evolving. So a very detailed knowledge of technologies is not the most important thing, but what you really need are concepts. So you need to understand the complexity of an algorithm, or you need some gut feeling, what is clean code? And it always helps if you know some software architecture principles. And as I can tell, when you join the industry, the language you have heard in Introduction to Programming will definitely be outdated. What also helps you as part of the technology is our very good tooling. For example, we have wikis, so you don't need to know everything, but you need to know where to look it up. A wiki lives on the participation of everyone adding knowledge to it. But this is also why it ages very fast. So you always need to be a little bit careful on consuming it. A very good example of a wiki is, for example, Confluence from the Atlassian software products. As already mentioned, another very good tooling is learning platforms. We are currently evaluating Pluralsight, which offers you really to create your own learning experience and to choose whatever you want to learn. What also might be interesting are the so-called technology radars. One of the most famous might be the one from ThoughtWorks, and it just gives you an overview which technologies you are not yet familiar with, which might become interesting, which might be on hold. So it's basically of getting to know your unknown unknowns and making them known unknowns. Then one of the most essential things in our daily work, the IDE, because it helps us to be fast, to be very productive. Some examples are, for example, Visual Studio Code, which also has a great assistance in remote pairing, and IntelliJ, Eclipse. I think there are a bunch of it. And another example I would like to raise for good tooling is the framework ArcUnit. It's a framework to have automated tests, and not only unit tests or integration tests, but also tests about the complete architecture of your software product.
So, what's also important in the projects is the documentation. So you have to organize your knowledge. And I think this is something that at least I haven't seen really well getting pushed from universities. There's either the C4 model in the Anglo-Saxon area, and in the German or German-speaking area, the typical example is ARC42. And the most important thing is to capture the why, not the technical details. What also really helps us is capturing decision records, for example, architecture decision records, where you have some options and some strategies, some principles. You have to make a decision. This decision will have consequences. It will have risks, and you might mitigate the risk via some things that you do in the product development. So thinking in that and capturing these systematically is really helpful.
Yeah, so good tooling really makes a difference, and we especially experience that now in the new remote or home office setup we're now all in. So we still use our standard like the Wiki Confluence, Jira for our ticketing system, and to have some remote code storage like Bitbucket. What's really new and very essential is to have some messaging system. We use Slack in our company because you really need to keep up the communication of teams to still have a very good teamwork. What was actually quite new are the virtual whiteboards. We can no longer use the whiteboards in our team rooms, so we needed some replacement. Good examples are here, Mural and Miro, and they actually allow more people to work at the same time than the real whiteboards because the space in front of a whiteboard is really limited. Then we have to use now some video conferencing tools, Zoom or Teams if clients prefer it. We use both. And then especially the thing you are now in, so our virtual office.
So some more words about our virtual office. It really helps people to navigate in the virtual world so we can all work better together. So we developed that in a client context and made it open source because it really helps us going through complex planning sessions, for example, in a safe environment, or scaled agile framework when you have the plannings. And we really trying currently to make this a little bit more popular and perhaps even giving that away for or making this available as a software, as a service offer, because it really helps people. So if you have something where you would like some improvements, or if you would like to try it out, just contact us. So what else differs? What really is something that is different from university is scaling, the amount of things we have to do and the responsibility. So what we do, often we have the responsibility for decades. And it's not only a few years, it's really sometimes a lot longer. And it's not only for the software, the process knowledge, it's also for the data. And that is often overlooked as well. We are working on the processor cycle speed up to hopefully several hundred years, where we will still be able to understand what we have done in nowadays. So this is something that is often overlooked, this long-term thinking. And I'm fearing that our predecessors will live in a dark age because we will have lots of software archaeology to do. And often it's not really known what people or clients need. So we have to help them with an experimentation culture, the lean startup way of thinking, really understanding what people need with design thinking and similar methodologies.
So, and once again, to scale, we need teamwork. That we are working alone daily, this happens very rarely. We are actually often even faster in pairing than if you're working alone on something. And in the IT, we often have to work together with 100 people or even 1,000 people, which actually has to work effectively and efficient. We have to deal with products which contain millions of lines of code, which actually one single person can't remember. Approximately 80,000 lines of code is that amount which can be remembered well by a single person. The rest needs to be covered by organization of people and the source code. So you can't do it alone. So the real challenge is to provide or to create a good team and to keep the team alignment. It's not only about technology, but about your teammates. So maybe it could be more part of the studies at university to prepare you to work together in a team. And we have learned studying psychology in some way together with software engineering is a very good combination to become a good software engineer and teammate.
So let's have a look at two real-world examples. One of our clients is in the governmental software area. The software was originally written in the 80s, and the base system was written in Uniphase. That's a fourth generation language system. And a lot of knowledge and a lot of corresponding data was created with that. This, of course, had to shift the technology stack, and it took now 10 years. We just celebrated finishing to migrate everything to Java last month. While that was migrated over this 10 years, it had to be able to incorporate legal changes all the way. And as it's not a small system, it captures a lot of knowledge. It has about 5 million lines of code. So after the migration is before the migration, because the next technology shift will be moving from Swing to web. And this will, again, take several years. And of course, also a huge thing to remember is that the data semantics changes due to the software changes. And this is especially important in that area that we are talking about. So no one really understands the whole system, and there were even parts that no one understood anymore, even with a lot of effort. And the team size is also interesting. That differs quite from 20 to 60 to 30, depending on the migration area and how much the client is willing to invest in that. And this also has a huge impact how you organize such a project. Franziska, how is your current project working?
So I'm currently working for a B2B and networking platform where we are supporting the customer in Scrum teams. And we're actually not just working together with consultants from TNG, but we are mixed with our internal colleagues, with the software engineers from the customer. What we're doing there, we're doing DevOps. So we're actually implementing and hosting our own stack. And this also includes even customer support, not the real first level support, but some second level to deal with problems. We are working on two different products, which also seem often like two different worlds. There's the old world, which is basically a self-hosted monolithic Java infrastructure, and it actually contains some 3 million lines of code. And the sad thing is that most of the knowledge has already left the company. So there is no one left which has implemented something in that piece of product we own. So it's very, very unfamiliar to us, and we still have to deal with it. And then there's the new world, which actually reads like a buzzword list what we're doing there. So we're doing some domain-driven design, event sourcing. We have microservices, which we deploy to the AWS cloud. We work with REST APIs, and in the front end with GraphQL and React. And in addition to that, we have a very high team autonomy. So it's upon us to decide, for example, how we want to design our microservices. In my team, we prefer Kotlin over Java, so Kotlin microservices it is. But this also comes with a very big challenge. We have to maintain, develop, and marry both worlds. So it's quite a big variance of knowledge we need here at this customer.
So if we have a look at all that, we have some wishes. How should software engineers be prepared, or what has to be looked at?
So what are we actually doing? We are learning by reading code. So in practice, a very big piece of or a very big part of our work is understanding what's already there. So approximately some 90%. You need to understand the code itself, the framework, the technology, the architecture. So there are really multiple levels you need to work with. And only 10% of our work are actually contributing something to that software product. So what we would wish for is maybe some research and in how navigation and understanding existing code can be improved. Another thing how we are learning in our work is we're actually learning by doing. And the best way is especially by pairing with an experienced colleague. So learning from someone who has done that really for a long time and just taking up some things he does in his work. So the question which raises is the theory at universities behind praxis at industry? And how to teach software quality in big systems? Because taking the maintainability or extensibility of a project or product into account on a design and implementation level was at least not part of my education. So how could we get there?
And that's something that I haven't seen so much. The first time I've seen that was in my last year of studies at Professor Brügge's chair. So I really was glad that that's the reason why I studied computer science, to see that software engineering part. And Professor Brügge was the first person at Technical University of Munich where I experienced that. And still, I think it's not enough in the real world. So teach more in projects, not in classes. And I have several ideas how to do that. One is improve open source. For example, I know Professor Ulrich Hafner at Hochschule München, here from the University of Applied Science, who creates together with the students tests and enhancements for Jenkins, a widely used open source continuous integration system. Or help people in need for having really projects that make a difference for personal lives of some people. Because then everyone sees that their effort is really worth it and it's not just for the draw, for the trash bin in the long run. And also helping with open source or other this kind of projects really is cool on the CV for the students. Or what you also could do is creating a virtual startup where a few students, at least a few students, learn how it is to act, to be like an entrepreneur, or helping startups or social software that really makes a difference. Something that is also, I think, often thought wrong in computer science is that we do projects. We are not doing projects. Don't teach in projects. Think in products. Think doing project management. Most software is done in products. Software is nearly never ever ready, never finished, even a small logging framework like Log4j or whatever. So as long as the software is used, it is improved, it's making, it's evolving. It has to incorporate changes because the world changes. And also software is so expensive to develop. So every feature you add to a software creates a burden, it's a liability, you have to maintain it. So try to avoid features that are not helpful. And therefore really invest in knowledge how to test that a requirement is really a requirement and not just a wish or a thinking of a stakeholder. There is data that shows that even in really good product organizations like Microsoft, only 1/3 of all features built is really helpful, useful. 1/3 is not really helping, but not at least from the point of usage, but it's not really improving the business. And 1/3 is not even helpful. And we have to get better at this as an industry, and also probably university could make a difference in telling and researching that more than currently. So think in products, not in projects. So a small wrap up.
Yeah, let's summarize once again our main points. In the industry, most people have no formal background at computer science, and this has a lot of consequences. So strive for the brightest ones. And maybe you are one of them. We are actually hiring. Then challenges in the industry are nearly always team challenges. So we should invest in knowledge and practice of team dynamics because they are essential. Think in feedback loops at all levels. We have seen quite a lot of them today in the talk, and hopefully you got inspired. Then create relevant time for explicit lifelong learning to make it also long-lasting. And let students experience the challenges of large systems. Let them feel what quality is to prepare them for the work in the industry later. And what we have just heard, teach in products, not in projects.
So that was our talk. And we are open for comments, questions, discussions, whatever.
Thanks a lot. I think it was a great talk and a lot of insights about how TNG is handling this. Maybe I can quickly start with the first question. You said that especially working with big software is not taught in university. And I fully agree that this should be much better taught, and students should be prepared much better for working with large software systems. But there's also the problem that this is also very difficult for universities to come up with big software systems. So I think collaborations with universities are needed from the industry side. And we have a lot of collaborations in our department due to Professor Brügge because he's well connected. But a lot of people in university are not so well connected with industry. So how do you think can we improve this? Is it the job of the universities that they have to go to industry and get some partners, or is it also the job of the industries to go back to the university and start collaborations?
I think it's both, of course, and but an easy example on at least larger systems is typically the prominent ones in the open source area. I think there it is nearly the same to work with like in industry, because you have bigger organizations who drive that. For example, 2 years ago, about 10% of our revenue was with creating open source projects for our clients. So I think this is a huge possibility to help in an area where it's needed, where it's open source, and therefore you can have a look at it and you can improve the usage for things that are used widely at industry levels. So I think with this open source area, you could do both.
Okay.
And of course, we have lots of interns that help us at projects and in products. We still say, even at TNG, we say projects, but it is products, of course. Where you have a look at these and can help and see bigger in-source projects. But still, I think at least in a lot of larger open source projects that are used so much in industry, the difference is really not big.
I guess one issue is also that you need some time to get used to large software systems. And we typically only have 3 months.
That's the point.
Yeah, we only have 3 months to teach the students something, typically. I think there are only a few universities who offer longer courses. So this is definitely one challenge for the universities, in my opinion.
But still, we as consultants have the same problem. We have to be productive in a new environment in a few days, or at least in perhaps 2 weeks. And typically this is possible. So it should be possible for students as well.
Well, in contrast to consultants, or let me phrase it differently, in contrast to professionals in the industries, students are not only struggling to pick up the subject matter, they're also struggling with picking up the concepts. So I think it's harder for the students to be
I don't
like
know,
that.
because more than half of our of the people starting at TNG are not with from a CS background. So I think we have the same problem in a certain way.
Are you expecting them to jump in and program Kotlin microservices the next day, though?
Typically, we have made the experience that after 4 weeks of pairing in projects, they are comparable to the not so good people in the project after 4 weeks.
So, but
Because
then
of
you
the
would,
pairing.
yeah, you would need professionals that are in the business for a couple of years that
Yes.
continuously work with these people for at least these 4 weeks, which is like one of the problems that is not doable with university industry corporations, just because there's no time to do that, maybe.
The other issue is that with our students, we get them for one course for about 12 hours a week over 12 terms. So I think that's, roughly 150 hours max. And so that's only a couple weeks of real world 40-hour week or 35 if you're in Europe time. And so that's another issue, is just, yes, we can have them do large projects, but if I'm going to have my best students work on a large code base, they're going to need 2 months to understand what's going on, just because they can't work on it for 40 hours a week. And so by the time they get up to speed, the term's over.
But isn't it possible to create more project-based learning experience in total, where you have not only 40, 50 hours, but several hundred hours in a larger system for probably also several years, at least touching it again and again? Of course, you have to change university and how things are taught.
I think this is discongruent not just with how it works at a university. I think this is discongruent with how universities are governed. For example, in New York, you could not do that in New York. It's at least not easily, right? Because if we suggest something like, do a project course that spans multiple semesters, then all of a sudden we don't only have to have approval by the department and by the undergraduate curriculum council, which are all committees on our universities. In fact, they sit roughly here. But we also would have to ask the faculty assembly. We would probably also have to, which is also a university committee, but we also have to ask SUNY, the State University of New York, which is the governing organization of our university. So I think this is, it's not impossible. I think there are also organizational hurdles that are going beyond what we have influence on as educators. And I would also say that, I guess I haven't quite fully understood the problem yet then, because if you say that, even if someone who is not technologically inclined you're able to get them up to speed within 4 weeks, then what do you need us for?
In a certain way, this is a question. It's really a question. What our experience is that you have to have someone with a CS background that helps a lot, because you will not run into several badly things, but you don't have to have everyone with a CS background. It's really the case.
Okay, I think we had a couple of people who raised their hands. I'm not sure who the first one was. Maybe Ishti, you can start with your question.
Thank you. So I'll just make like 30 seconds comment, and then I'll get to my question, if I may. So when I was doing my PhD, I went to Microsoft for an internship, and it was a great shock. I realized like I was so backdated with technology adoption, using tools. I was like at shock and how can I manage this? And it was like 12 weeks of internship. They had a mentor for me, but she was super busy. She didn't have the time to sit with me, teach me things. So I saw the gap, what we learn in school formally and what we need in industry. So when I graduated, I actually worked for industry for 4 years. Then I finally joined academia as an assistant professor. So it's my goal to bridge that gap. So I would like to talk a lot. And one suggestion you just gave that I actually implemented is that help people in need. So when I teach the software engineering course at my university, I actually send out an email to all my faculty colleagues saying, hey, do you need anything that you need to implement in like, that's not very high stake, but can be implementable, and we can help you, try to help you out. So I get a lot of feedback, and we are actually working in a class scheduling algorithm that our division head is supposed to use next semester. Now the question is, one of the common mistakes in software development is to get rid of or handle the bad apples. Like in my team, I have some students who are really not up to the speed, and they're like keeping the other team members down. So how do you deal in your organization the bad apples, like the ones that are not contributing or just having issue with other team members?
That's a good question and an important one. The recruiting department at TNG typically doesn't create this problem, but we do have the problem with the clients or other consultancies that are also engaged at the clients. And this is a tough question, and often it's the case is that not everyone fits into all projects very good. And sometimes it helps to define or create a new role. And I have seen that very successfully. Sometimes that people are more interested on the business side or on the testing side or whatever, or move out of a certain area because they are not fast enough. They are not really, it's like when you introduce agile software development at departments, at clients, I would say 10%, 15% will drop out. They will not be happy in these environments where everything will get visible. And currently with the pandemic, this is even increased, that you see who really contributes something and who doesn't. And this is a challenge because people see that they are not contributing, and that makes them unhappy. I can't change it. You have to have some tough conversations and to talk to clients what these people should do in the future. But you have to address that.
Yeah. Thank you.
Okay, I think Bernd, you have to be next to raise your hands.
Okay, thank you. Thanks for your talk. I would like to ask a follow-up question on these 4 weeks that you mentioned some questions ago. So what exactly happens in these 4 weeks? Imagine we have somebody who just obtained his or her master degree in computer science. What happens in these 4 weeks? And in particular, what are your favorite misconceptions? So what did you observe during 4 weeks from new employees coming from the university, where you said, oh, that's an interesting view. How come that you view it that way? Actually, it is this way around.
So, Franziska, I think it's okay if I answer.
Yes, go ahead.
The first things that we do is that we lay out our mental models a bit. So after the first day, where you just get to know how things are working at TNG, we have a 3 days course with the fundamentals of software engineering, where you at least hear something about agile software development, test-driven development, IDEs, shells, Unicode, encoding databases, application servers, whatever. So this is really intensive. 3 days, really, really intensive with all the people that start at TNG at the same month. So that helps to get at least the unknown unknowns to known unknowns. After that, you get really fast into your first project. And what you do there is you pair immediately with other people. And they show you and explain why things are like they are. And that is the speediest process that we see, what works. And then, of course, we have our tech days as well, where we have, at least for the first half year, a curriculum where people should take part. For example, doing a Kanban and a Scrum workshop and really experience things. Not only on the theoretical point of view, but really inside some safe learning environments. The things that often are not understood, even if people have prior knowledge in some computer developing things, especially is test-driven development and the rigorosity that how clean you have to work to really get results. That is sometimes for people really astonishingly. Franziska, perhaps you have some additional thoughts, because I'm at TNG from the beginning, so it's a little bit difficult sometimes for me.
Yeah, so what was maybe the most essential thing for me is actually you need to raise questions. You should never be afraid to just ask, and you should ask really a lot, because you're working together with experienced software engineers, and you just need to kind of get something or consume something of their knowledge, and then you just see them working. And what actually also helped, so for me, I have written some sort of learning diary where I was just writing down the technical stuff, but also like how do others behave? How do they answer phone calls? So there's a lot of things you need to learn in that new period. And yeah, of course, then it helps the tech days to have some safe environment where you just search yourself someone or ask someone, hey, who knows technology X, Y, Z, and can maybe give me some introduction or show me some things. The most important thing is to not be afraid of asking.
Okay, thank you. Quick follow-up. These 3 days introduction is like lecture style or exercises, or how does it look like?
I have just given one week ago, so it's really, we kind of try to make a mixture out of lectures with some interactive questions, but they also get some VM where they should or are actually asked to follow the steps we do to have, for example, already once created or initialized a Git repository. And then there are also some tasks where they should just work and try it out on their own, and we're trying to consolidate it afterwards together. So it's a complete mixture of types.
Okay, thank you.
Okay, I think Thomas, you have the next question.
Well, yes, my question is, you also people from different domains. You mentioned not only computer science, or is it also possible that, for example, person with a degree, with a bachelor master degree in economics or in physics, or also can also apply for you at TNG?
In principle, yes, but we need the analytical thinking way to fit to TNG, and this is typically not enough available when you have studied, for example, a BWL.
I mean, business administration.
Yeah, we typically don't get these people. They are not fitting us. You have really this analytical mindset. And you have you need the rigor of really working through something very disciplined, because otherwise it will not work.
So maybe someone who is studied economics, maybe micro or macro economics, and with specialization, for example, in economical statistics, like that, or econometrics.
My brother is a professor in econometrics, and he's programming more in Fortran than me. So he's more programming than me. He's also doing Fortran that I haven't done ever. So that's really funny. When we exchange, we just talk.
Because where would you? Ah, okay. That's interesting. It's interesting.
He knows more than on computer cycles and clock times than me.
Many people who studied economics, they switched to computer science. They working as programmers today, because they did not find a position especially on economics, maybe in econometrics, the statistics.
then they learn programming, and also they're working in the field of software development, computer science, also in the field of finance, but also in industry.
But more typically in the SAP area and not so much in the, we are a little bit coming from the open source Linux Java way. So we have really open thinking people, and often it's the people with that background typically sometimes are a lot more into this SAP ecosystem that is a closed ecosystem in its own. Typically, that's not where we fit in really well.
Okay. No, I only ask because I know also someone who is working in the field of she's an economist, and she has been working in the field of the statistics, and last time in the field of supply chain management, but she has a big passion for natural sciences. Already in school, the favorite subject was physics, and she's more interested in the field of maths and natural sciences. That's the reason why I ask. That's also the reason why she decided for a career in the field of statistics, econometrics.
Okay, I think Ben, you have been the next who raised his hand. You're muted right now. Can you unmute yourself?
Sorry, Zoom is hard. All right. Yeah, just to follow up a little bit with Ishi's question about the evaluations, because I know in academia, it's hard to evaluate team performance, and it's hard in industry as well. Now, you also have the extra input of clients, which I'm curious, do you use that in the evaluation? And actually, can you be a little bit more specific on how do you evaluate people, and how often do you get dropouts? Like, especially out of your kind of initiation program, how many people drop out of that?
Not a lot. I would say one person per year, one
Oh.
colleague per year. So we sometimes give people a chance that we are not really sure, and sometimes these are dropouts, but it's not so often. If you have a look at what we do quite often is probably a bit unfair, but we look at the grades at especially school, not so much of university. And if you have a good German Abitur, I don't know what's the term in English, I have no idea. Typically have people having really good grades. So for example, in Germany, something between 1.0 and 1.4. This is a typical range for people starting at TNG. So we are probably not the total normal IT consulting company. And also, so yeah, therefore, and people who have done a PhD, they know how to suffer something through. So they know that they have to work on something for a longer time, and they will get to a positive end. At least they have experienced it when they start at TNG with a PhD. So this is also something where we think this just helps, that you know that you have to work to a bigger long-term goal, and large software systems are not easily changeable. So you have to pursue until you are somewhere where you want to be. And if something takes 3 or 5 years, it's okay, because the long-term goal is worth it. And I think this is a difference between a lot of people just doing programming and creating real impact. So perhaps this is one of the explanations. I'm not sure.
But there's always somebody that's not making it. And I found that oftentimes the people that aren't making it think they are making it. It happens at the university as well, right? And I think that's why teams struggle. You know, somebody thinks they're contributing, they say they can, but they're not, and they should really fail. But and it happens in industry too. And I'm wondering, how do you find those people? Like, I find them in the sense of, you know, identify them so that you can let them
Good
go.
grades.
Or
Good
correct.
grades are one of the key indicators for that, because
No, but
for
I'm talking about after you've hired them.
how do
So like
you
they've
have
been
to
with you a
give them
year.
freedom. You have to create an environment where they thrive, where they are lucky, where they can change the world and have an impact. I think intrinsic motivation is one of the most important things, and of course money. At least Munich is not so cheap, so you have to pay them money. And having great colleagues is something also they extremely love. To have colleagues that are intelligent, nice, helpful, have an environment where you don't have processes that don't make sense and so on. Andreas,
but what
probably
happens
you.
when it doesn't work? I mean,
Yeah,
surely
that's what I wanted
doesn't.
to add. One thing that, so I'm one of the colleagues of the two. One thing that we do a lot is we have a lot of feedback loops. So we have different levels of feedback. We have one project, one person in per project who is doing a lot of feedback discussions, like one-to-ones, in actually pretty high frequency, even especially in the remote context. We do them like every 2 weeks or every 3 weeks, where we just sit together and talk about how things are going and how one could improve, and how the project is going and how the personal development is going. And if you talk a lot to people, you will notice how they feel about what they're doing in the day-to-day job, how they want to go on. And in these discussions, there's sometimes the case that you just find out that it just doesn't fit. So both TNG and our colleague thought that they fit it, and they didn't. And most of the time it's then just going apart again. It's not like you have to kick them out because they think they're doing well, but they don't. So, but if they don't do well, you just tell them, and then you might find out why that is, if that can be changed, and if it's not possible, then you have to go apart.
Okay, so officially the time of the session is over, but I think we can hang around here a little bit more and chat a little bit more. I would also remind you that we have some networking features in Virtual Office. So if you scroll up, there's a button, Networking Join. You can also get into random rooms and chat a little bit with each other. I think this is very important for conferences, also for virtual conferences. So feel free to leave now. The official part of the session is over, and I think everyone who wants to stay can stay a little bit longer and chat with us about the topic of the session. I want to thank Gerhard and Franziska again for the great talk and the great insights from industry. Thank you again very much. We really appreciate this, and we also appreciate your help with setting up the virtual conference. Thank you again, and in case people have more questions, feel free to jump in.
Thanks for giving us the chance to speak at this conference. It was an honor.
Yeah, really. Thanks a lot.
Gerhard, Franziska, I have like 2 more questions, if you may.
Sure.
Of course.
Very interesting talk. And I'm always asking this question, thinking that my students are going to your organization. So first question is, like, when you pair someone, a new hire with your mentor, so do you just do it randomly, or do the employees get a chance to choose, or do you have any metrics to use to figure out who should you assign this new employee to pair up? This is question number 1. And question number 2 is just, what's your interview process? Like, when you hire someone, what should I teach my students to be prepared? Like, does doing programming contests help? Because this is just small projects, right? If you do a programming contest, it's just a small problem, you solve it, you are done. Does that help to pass your interviews?
Franziska, you've gone through that. I haven't.
Yes. Yeah. So which question shall we answer first? No, maybe the interview quickly first. So I think we have quite a long interview. I think it's often takes some 3 hours, if I'm not wrong. And it's actually about some personal fitting, so where you can kind of try to find out if the persons and the company is fitting together. Then we usually have some part of it where it's just some analytical thinking task. So it does not have to do anything with programming or implementation. It's really just solving problems. And what's necessary is not really that at the end you have the perfect solution, but it's more about like getting to know the thinking processes of this person, to see like what kind of steps is he following, and also can he communicate his thoughts, because that's important for teamwork. You don't have to solve later problems alone most of the time, but you need to be able to talk about the solution finding. Mm-hmm. And then we also asked the applicants to give some rating on technologies and languages which they already know. And then the third part is some implementation question or some more technical or more, maybe you have to implement a small program on the whiteboard back when it was still in the same room.
What we really think is helpful if you are a little bit passionate about the things that you do, and that you can really talk about them. So it's not really important what you have done, but that you can talk about the stuff that you have done, and that you remember at least the important concepts of what you have done, and can you communicate them. From the staffing perspective, of course, we'll try to match people with more experience and people with less experience. But as an IT consulting company, we often do not have a lot of possibilities. We have a lot more demand on us than we can handle. So we are typically fully booked. And that's a good thing, even in Corona times, yeah. But that limits the possibilities to have an exact match. So we, of course, ask the people sometimes who were part of the interview, or have at least the recruiting department give some hints about the personality, and then we try to match the people together for new projects. But that often also involves other stuff like where do they live, because people shouldn't travel too much. And so there's a multi-dimensional problem that we try to solve as best as possible, but there are limitations, and we expect that people at least try to work together. And often that works out well enough. Yeah. So if you have this culture of helping, of learning, of having lots of feedback loops, then nearly everyone can work with everyone else. So that's at least our experience. So it's not so dramatically important if you have at least one or two more experienced persons in a project. And then we have the new hires from university, and they learn fast, and they help after 1 month, probably 2 months, they already helping and having a positive impact. And of course, you need clients who accept that, and that is not always the case. So there are sometimes limitations on which kind of projects or customers we can accept, because if you have customers who only accept the most senior guys or girls, sorry, that's not helping us, because we are growing with 20-30% per year, not this year, but in the recent years, in the last 10 years or something. And therefore, we need the opportunity that we can show that intelligence will play a certain role in the project.
Thank you. Thank you very much.
You're welcome. Christopher.
Hi. So I actually have several questions, but I'll temper myself and just have one comment and one question, if that's all right. So the first one, nice and quick, it's giving back. So your comment about thinking about products rather than projects is very good. Practically, I don't know if it will change too much, but there's a sentiment behind it which will change what you might do. So that's something that we do, is that we have a forced requirements change in one of our courses. So we set them out, they actually define their own projects. They get about 2/3 of the way through the project, and we go, right, now you've got an additional requirement and you have to implement it, and it's likely going to be conflicting with something else you've already got. So it's trying to get this whole, change of requirements, awkward customer sort of bit to it. So that's something that we do, and it works very well. The students usually get frustrated in the short term because they're making their baby, their projects, and then something's going to change, but then they really evolve with it, and it works quite well. So that's just simple. My question is different. Virtual startups was one of your suggestions.
Yes.
What do you think? How would this work in your view? What would be the core key parts of what a virtual startup would be in educational perspective?
I have been part of several hackathons, so where you really try to do something that might have an impact. So that where you really go out on the street, talk to possible customers, and really try to understand that loving the problem, not the solution, is key. And that where you really work with people that you probably haven't seen ever, and do something in a certain short time frame. And it's astonishingly what you can do with people in a few days. Yeah, think a little bit in a design sprint, Google design sprint way, or something like that. Yeah, I would say that seeing that you have to have the right questions, the right hypothesis, and that you have to have a lot of rigor in finding answers to them, that your hypothesis might be wrong and often are wrong, is helping. I've been part of one where a startup was taking part that had already 3/4 of a year worked on some problem. And after these 2 days of this hackathon, they saw that they're solving the wrong problem. And that is cool, yeah, to see how much impact that has, and also working together on something together for the sake of the thing that you do, the possible impact that it might have is so strong, so cool, that I would love that everyone should have this experience, to go through this experience. And this is something that you can't tell or teach at university. You have to experience that. It's so strong. And if you've seen some of that, you will never go back, and you will never say that can be done by classes. Yeah? Go out, create a company, learn the things that are necessary, or simulate it in a certain way. And there will be people who are not really in that. But if you just increase the chance that not only 10%, but 30% will be have this Selbstwirksamkeit. Who knows English well enough to translate Selbstwirksamkeit? This experience of being able to change the world in a positive way, and that you can make an impact, a large impact. It's so cool if you have made this experience. And not everyone has done that at school. And it should be part of school, normal school education, probably when you are 13, 14, 15. But at least when you are a young student, you should be able to experience that. It's so strong. Does it answer the question a little bit?
Yeah, no, perfect. Thank you very much.
You need self-confidence. You need to focus on the self-confidence, what you can do, and to be encouraging. Yes. Okay.
I hope I pronounce your name correctly. Is she? I'm sorry.
No, perfect. Fine. My name is Ishtiaq Hussain, but I go by Ishti.
Ishti, okay. So you raised your hand, so I was just...
Oh, actually, I raised it earlier. I forgot to lower it.
I see. Sorry.
I really enjoyed this talk, and I'm just taking notes, and hopefully I will make my students watch this video after it's published, because I think that the discussion that we had, like having this startup experience, helping others, changing the world, these are really resonates me. Like I see that motivating the students to contribute back through their learning might be a good approach in teaching software engineering. So thank you very much for that. insight.
And probably also with other faculties as well together, like the I-Praktikum, I think, at the University of Munich, where from different backgrounds, if you combine people from different backgrounds in courses, in projects, in helping others, it's so cool. For example, from electrical engineering, from robotics, from whatever. It's also the way of the future, I think, and not having the silos that you have typically at universities or in education at all, that you really try to overcome that a bit, and that you know how important it is to work with other backgrounds. So this T-shaped people and design thinking a bit, to make that a little bit more reality. That would be cool.
So just to jump in on that, sorry, there's a challenge-based learning. So everything you've just said seems to resonate with challenge-based learning. It's getting people from multiple fields, computing, design, management, whatever, working on real problems and trying to do this. So it's doing things that you're asking for. How it integrates with the university is difficult, but some universities definitely do it. There was one in the Netherlands. I'm just trying to remember which one it was. Doesn't matter, but sorry, I didn't want to interrupt Grissa anymore. Sorry, Grissa.
I think the Netherlands are really in that a little bit more in design thinking and so on. And yeah.
Yeah, I think.
And I think Stanford is doing quite a lot in that.
I mean, what Christopher just said, I think I got the point. Like as an educator, as an instructor for a course, we are assigned designing the course, evaluating the students, and now if we have something that is open-ended, how do you evaluate? And I really struggle with the piggybackers. Those are the students who are taking 6 courses, and they happen to be in my course. They are just there without doing anything. And now that it's an open thing, people can come up with their ideas. How do you evaluate? Do I give a grade C? They will complain. If I give A, that's not great. So we have to like balance with the project and with the theory and the evaluation. So it's really hard to fit everything in this just couple of weeks of course.
Mm-hmm. Yeah, we don't have that problem. We have we have clients who pay us for doing this.
Yeah.
But yes, I understand the problem. It's not easy. I'm sure it's not easy.
Yeah, we have another problem, is in my country, the students are very young, and they are learning a lot of personal competencies, and they have to learn to work in teams, and that is a big problem because when they have a big project in long time, usually they finished fighting each other, and it's very hard to continue with some projects. And also the motivation is very different. I don't know, because you say, yeah, a PhD in your company have the motivation of the money and have all the knowledge, but the students doesn't have that. That's the problem. They don't have that motivation. Maybe you have some ideas for us for motivate our students in long projects, and I don't know, to stay motivated in these courses, because we don't have only projects for all the courses. They have a lot of projects, and also when you incorporate a new element in the team, it's very hard for them to explain all from the beginning. They have to arrive in some point and say, yeah, we need to continue because you are new and we don't have time for explain all the past. What do you do in your company when you have to incorporate a new element in the team and continue moving forward, not to see the past?
I'm not sure that I understood everything, but I would say do projects that are really, or might at least have the possibility to have an impact for intrinsic motivation. I think this is the most important thing to do. Don't do projects for the project itself, but do the project to make the world a little bit better. And I think the good students at least understand that and will work on that because of this intrinsic motivation that they get by doing it. Other than that, I think also what helps is if you really mingle different experience levels sometimes, where they see what can be done after a certain amount of effort, that they see what is possible and have this regular feedback sessions. So what I probably would suggest is that you have with students, not with the professors, but with students that are a little bit further, regular checkups. And see if they could help. So we have a buddy system, for example, for new employees, not only the one-on-ones in projects, but a buddy system. When you join TNG, you get a buddy for a certain amount. I think it's half a year or something. And often they know them so well, and they, of course, get friends or something. Not always, but it happens. Where you have someone you trust who has gone through the same, not too far away, and can give you feedback on how you go overcome certain challenges. It's not that people are responsible for their body, but they know how they experience things because they have gone through that 2 years ago. So I think that might be a way also to help students go to certain downs, or how they can reflect how their effort would probably make a change.
Yeah, and regarding the onboarding of new team members, what actually helps a lot on our side is to have documentation. And here you need to be a little bit careful. So it has to be the right documentation, not everything, not every technical detail, because this might be already outdated, but at least something like a decision record where you can see the most important decisions which have been made, to kind of follow not the complete path, but at least the path which was finally made for the project, to kind of keep track of that.
So that's a good point Franziska makes. For example, if you follow the rules of for example, arc42.org, you get about 20 to 30 pages for 1 million lines of code, so that you really can understand your impact on the whole system, where your work fits in. And I think this is often overlooked, that you are able to do this.
I said, yeah, the documentation thing. And the students really hate it, but we can try.
Yeah.
It's professionalism in a certain way, that this is done in a rigorous way. We do, for example, everything we do at TNG is at least a 4i thing. We make reviews on everything. On documentation changes, on source code, on tests, on user stories, on requirements, whatever. Even on offers to clients. You always have this 4i principle on everything, and you have to get used to it. You have to embrace it to be successful, because otherwise, you get, if you don't do that, not good. That's probably something, Franziska, we should have added to the talk, this 4i principle, that you always need someone else to have to look at what you have done, or even done by pair programming or whatever. But if you don't do that by pair programming, you have at least the 4i principle. And this is also one of the feedback loops that really works well.
Yeah.
So,
yeah. Any further questions?
Not a question, it's a comment. You mentioned about creating a buddy system. It's interesting because in psychology, one of my colleagues actually worked a concept called battle buddy. He was in military, and he saw that in the military training, they assign you a battle buddy, not to just check each other's back, but also be there for psychological counseling. And they're trying to use that in the classroom by hiring a student who has already taken this course to just be there and be a battle buddy. So it's been trying out in courses, but we'll have to see like how it results. But it's interesting to know that you guys are already using that in real life in your company.
I think it's used in a lot of companies.
It's used in the NHS because of COVID. In our National Health Service in the UK, it's used by doctors and nurses because of COVID.
Wow. Okay.
I think this is one of the things that I'm not always understanding. What we do at a company level is not often done in the education system, like having good notes, like wikis, knowledge management, nudging, regular feedback loops and all that, sharing of everything, having reviews on everything. And I don't understand why. For example, when you get to be a teacher in Germany, you typically, everything how you teach is yours and not given, shared with someone else. And I just don't get it why. Because we wouldn't succeed as a company if we would be like that. But it's accepted in schools, in universities, and I don't understand why this is the case. Why are people like that?
So I have a hunch, and it's open for discussion, and it comes back to your earlier point about us not working with larger projects, either in size, millions of lines of code and so on, or length of time to make them. When you're doing something over a 3-month period and you're only seeing them for a day, they're only doing a day a week of work because they've got other courses they're doing in parallel, you wouldn't make a wiki to support that alongside it. You wouldn't do all that thorough documentation alongside it because it takes time. And the benefit is beyond the 3-month period. That's when other people read it and so on. So it's not part of what goes on. So it makes sense in that perspective. But then to get that and then to start thinking, okay, how can we educate with those techniques, tools, whatever? We need to then work with those larger projects. So if we can figure out how to do that, I'm confident that that is perhaps a bit too challenging with current degrees because they cover such a range of courses. You have people coming in with perhaps no programming knowledge, and we're teaching them introduction to programming, data structures, all the way up to software engineering and databases and networking and operating systems, blah, 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 blah. But perhaps there's an argument for an alternative degree where you might do something like that. And it always, it rings a bell in my head of, it sounds more like an apprenticeship or, simulated startup, as you said, but have that as a course on its own.
As you had, or as you mentioned, the documentation and wikis as an entry point, one thought that I had on my projects I did in university, I always also had to hand over some project report, so something writable, and then it was not really in a format of a documentation. So why not maybe just say, let's write a good documentation for it and hand that in as some sort of project report. There's the ARC42, for example, we mentioned. And I think I would have gained a lot of it if I would have written or would have had to write such a project report, which actually would be some good documentation rather than the thing we usually did.
Yeah, I love that idea. I love that idea. The thing that the tension that comes to mind immediately after that is, well, why do we do it the way we're currently doing? And that's at least in my university, we're teaching primarily computer science, not software engineering. We do now have a software engineering course, but it has a lot of foundational computer science modules because we're catering for people who don't have a computing background necessarily. And it comes essentially back to when they do their final reports, they are doing it from a computer science perspective. So they are doing what's the intrinsic motivation? Let's talk about background. Let's perhaps cite some papers that suggest these sorts of things. So they get to think about ideas and concepts a bit more, but not necessarily from, say, software engineering documentation point of view. So perhaps that is an argument for, okay, let's take this as the ones doing properly software engineering, and we can do something like that.
Yeah, and I think a lot of the things you mentioned, like where did you get ideas from, this also has some place, for example, in the ARC42 documentation, but maybe under a different aspect. So maybe that's worth trying it out.
Yeah, super. Right, I'm going to run away because I have a toddler that I need to go and, or a wife that I need to go rescue from a toddler. Thank you very much for the presentation and also the virtual office. Yes, it's a great tool. I'm going to be looking at it just so I have it on the back burner for any other future stuff.
If you want to,
yeah,
open for requests.
Yeah, no, it's if we start actively using it, then of course there'll be pull requests and discussions for stuff. But yeah, no, thank you very much, and I'll catch you in future sessions.
Yeah, thank you also.
Thank you very much. Also, was really very interesting. When you're walking, hiring persons, and how you start to teach in ongoing period. It's more the process of learning by doing or learning by experiencing. It's also my research field because I just wrote my PhD thesis. It's on further education of software testing experts to Internet of Things testing experts.
Oh wow!
So to pick them up on the current level of knowledge, as well professionals or the experience who are interested in. They have already been working for some years in the field of software quality assurance, and now they want to learn IoT testing, but also for students at universities, also apprentices to plan a further career in this field. And there's especially important. So my research objective is more on the focus where to pick them up on the current state of knowledge and the current experience level. I think the approach is similar.
Cool.
Good. Yes, was really interesting.
Thanks.
Thanks for being part of our session, and let's probably we see you again on the conference.
Yes, I join the next session at 6. It's a software engineering games workshop.
Sounds like fun then.
Thank you.
Bye.
You. Bye bye. Bye bye.